anything goes. Anything you want to talk about. If you want to talk about current slide, if you want to talk about something that we covered earlier during the class that just came up to you, feel free to talk about anything, ask questions. And during the live stream, we try to avoid machine-specific questions. In other words, if you have a question that you think only relates to, say, a Probot P12, we try to avoid dealing with those during the live stream, but we have the next 2 weeks in the online group to cover such questions. Anytime, any type of question at that point will be fine. But during the live stream, let's see if we can focus mostly on questions that apply to as many people as possible. So let's get to it. Every time I work on a new roasting machine, I am most concerned at first to make sure that the machine is what I call tuned. And the thing about these considerations is that if any of them is not set up well or adjusted well, no matter how hard you try, your coffee quality or consistency will be somewhat limited. And making sure that all these things are in proper adjustment is the critical first step in using any machine. When it comes to drum RPM, the optimal RPM is primarily determined by the diameter of the drum. So the larger the diameter, the slower the optimal RPM. This applies mostly to classic drum roasters. If you have an air roaster with a drum, for instance, you need an RPM that mixes the beans well, but you don't have to worry about having a precise optimal RPM because you're not worried about conduction. So when we roast, we have two sources of heat transfer, convection and conduction. Convection is the heating of the beans through the hot air that passes through the drum, and conduction is heating by direct contact with the hot drum surface. Now, I'm going to often talk about minimizing conduction and maximizing convection throughout the class. Conduction isn't necessarily bad. If you are looking, for instance, to have heavy-bodied coffee and you value the body more than you value the flavor clarity of the coffee, then you might want some conduction. So for example, if you roast dark and primarily roast for espresso, you probably want some conduction in your roasting. But if you roast very light and are concerned about flavor clarity and not so much about body, then you probably want to maximize convection and minimize conduction. So these RPM levels, again, are mostly determined by the diameter of the drum. They can be influenced a bit by the pattern of the mixing vanes or paddles within the drum, although that's a little bit challenging to talk about in a general sense. We can discuss a few quirks in machines that have optimal RPMs that aren't that don't quite conform to this. Like for instance, a lot of Gießen machines tend to have optimal RPMs a little bit higher than these ranges. The reason these are ranges and not precise readings is that not every machine of a certain size has a drum with the same proportions. So in other words, if you have a 15 kilo Probot UG, you have a relatively wide and shallow drum, which means that the RPM would be a little bit lower than, let's say, a 15 kilo Joper, which has probably the narrowest and longest drum in the industry. You'll notice that batch size does not affect optimal RPM. That's not very intuitive, but regardless of whether you are roasting 1 kilo or 15 kilos in that 15 kilo machine, the optimal RPM is about the same. Bean size does have a small effect. Larger beans tend to prefer slightly higher RPM. I would say that this effect is trivial enough. I wouldn't worry about this too much. I would mostly just say, hey, I've got a 15 kilo machine, my RPM is 53, I'm happy. I'm not gonna worry about it past that point. It gets a little bit risky to be adjusting the drum RPM all the time, especially if you think about how beans expand during roasting, and it would add some complexity to your roasting to have to change the RPM a couple of times during the roast. And for instance, you might forget to change it back. When you change the RPM, all of the data points on the curve shift a little bit due to the change in RPM. So it's probably not worth changing RPM when the beans change size, whether it's a different batch or they're just expanding during roasting. When it comes to the gas, your gas valve should have a sticker on it that says something like operating pressure 10 to 50 millibar. And if you have, for instance, 30 millibar of incoming pressure, and you were to ring up your machine's manufacturer and say, hey, it says 10 to 50, I have 30, is that okay? They will always say yes, because it will work. But what they usually don't tell you, and what's important to understand, is that you won't have the full productivity potential of your machine. So if you have 30 instead of 50, you'll have roughly 60% of the productive capacity that you would have at 50. So you might, if you were to say roast full batches, you might have to roast them a lot slower, or you might have to roast, let's say, 60% batch size to get to the same roast time as you would with a full batch if you had a higher gas pressure. So please keep that in mind. Some machines like Loring and IMF require a certain pressure range to work properly, and once they work properly, it doesn't matter where in that pressure range you are. Your flame should be about 90 or 100% blue. If it has a substantial amount of yellow or orange in the flame, you might need to adjust your air-fuel ratio. If you have an old-style atmospheric burner, you might find that you have to change the airflow level in your roasting to affect the combustion. If you have a more modern fuel injection style burner, you probably need a gas contractor to come out and turn a screw that adjusts the air-fuel mixture to give you higher quality combustion. Doing that will save you some fuel. It will help prevent excess carbon monoxide production, and it will probably help you keep the drum surface in your machine a little bit cooler. There's also a separate thing called valve tuning. Some of the more modern fuel injection burners are integrated with the control panel on your machine, and it's possible that you don't have access to the top end or bottom end of your burner's potential settings. And if you ask for the valve tuning PDF in those situations, you can, for instance, get access to slightly more precision at the low end of the burner settings, or a little bit more power at the high end. I wouldn't worry about this unless you feel like either you're in one of two situations. One, you have the maximum allowable pressure for your burner, but yet your machine still seems a little bit underpowered. Or no matter how low you go with your gas settings on the control panel, your ROR tends to rise before you reach first crack, and then you tend to see a pattern of the ROR rising and crashing and rising again. If that happens despite using very low gas settings going into first crack, then it may be that you need to tune your burner. And it's a very easy process. It usually takes less than 5 minutes. Christina, do we have any questions yet? Okay, so keep moving. When it comes to airflow, things are a little bit more complicated. The more obvious functions of airflow during roasting is that airflow helps remove chaff and smoke. So it's pretty easy to tell if your airflow is too low, because if you open the roaster door at the end of a batch, you might see a lot of smoke come out, you might see a lot of chaff come out. And if you taste your coffee and it's not a particularly dark roast, but it smells a little bit smoky, could be an indicator of low airflow. But excessively high airflow is not obvious, and it's difficult to, there's no indicator of excessively high airflow that's obvious or intuitive. So when the airflow is too high, what happens is you are pulling heat out of the roasting chamber faster than necessary, and that requires a little bit more open burner valve, so basically a larger flame, in order to compensate for that heat loss. So when the airflow is higher, you would assume that you're getting more convection, but in a typical classic drum roaster like a Probot, Giesen, Diedrich, etc., when you have higher airflow, what's happening is, yes, the air is moving through the roasting chamber faster, but the air is cooler. So the gas valve is at a certain setting, let's say 80%. The burner is at a certain temperature, and then when you increase airflow, you're just pulling that air faster through the drum at a lower temperature. So you're not actually getting more convection because the air is cooler. But since you are pulling heat out of the drum faster, you're going to need to adjust your flame larger in order to compensate for that heat loss. And that larger flame is going to make the drum surface hotter. So what happens when the airflow is too high is that you get more conduction, and that makes inner bean development a little bit more difficult to achieve, and it makes the coffee potentially taste a bit roastier if the drum surface gets too hot. So one of my clients a while back had a 500 gram drum roaster that he used for sample roasting, and I never had good coffee off that machine. Everything I tasted from that machine was either a little bit roasty or a little bit underdeveloped. So one day I said to him, let me just take a look at this machine, because there's something wrong with it. And I realized that he had the airflow setting about 3 times higher than the amount of airflow I would have chosen. I lowered the airflow quite a bit, and that allowed me to use a much, much smaller flame to reach the same outer bean color in the same amount of time. So once I made that adjustment and then found the gas settings that would bring us back to the same 11-minute roast he was at, the weight loss of the roasts went up by about 1 point on average. So that's a pretty large jump, considering that the outer color was the same. And what that told me was we got much more inner bean development. And the reason for this is that when the beans are touching the drum at one spot at a time, heat will enter the bean from that one spot, and that spot will get a little bit of surface damage. But when you have convection providing the heat transfer, the heat wraps around the entire bean and penetrates the bean from all angles at once. So convection is a better penetrator and developer of the coffee, whereas conduction can do some surface damage and doesn't develop the inside of the bean quite as well. Okay, a couple questions. Okay, so the first question is, would I use more airflow for a darker roast? And it's actually a tricky one, because if you are roasting pretty light, I would generally recommend beginning your roast with the lighter test, such that when you put the lighter up to the next to the trier, about 1 centimeter from the trier, in the first half of the roast, you should see the flame pull ever so slightly off of vertical. And when you reach about bean temperature 160 Celsius or about 320 Fahrenheit, I would recommend increasing the airflow so that you get a 45-degree pull, which is just a little less pull than what you see in the cigarette lighter test in the image. If you're roasting extremely dark, it is possible that you would be developing enough smoke per unit of time at the very end of the roast that you'll need a little bit more airflow than you would need at the end of a light roast. It's kind of a case-by-case basis, but I would say in general, you don't need different airflow settings for a dark roast unless your dark roasts are significantly darker than your light roasts. So if you have a third wave type roast level with maybe weight losses of 11 or 12%, and you've got say a Starbucks type roast level of say 20%, then I would say you might need a higher airflow setting during the last third of that darker roast. But if you're more like a typical roaster using one roast level for filter and a slightly darker roast for espresso, then you shouldn't need separate airflow settings for your darker roasts. The cigarette lighter test is just there to show you whether you have some negative pressure or some draw. And I came up with the test as just an intuitive way of sensing whether you're using enough airflow to suck smoke out of the drum. And I used it on hundreds of machines over time and realized that it's a pretty good ballpark indicator of the right airflow levels. And it generally works in pretty much any classic drum roaster, and it will tell you if you have negative pressure in any machine. Okay. Somebody asked what the other consequences of too much airflow are, and the answer is that there are none. If you read internet forums, a lot of people will say things like having too much airflow strips beans of moisture. That is not true. It's actually demonstrably not true, because if that were true, you would be getting higher weight loss readings by using excessive airflow, but it's actually the opposite. When you use less airflow, you end up getting higher weight loss readings relative to the outer bean color. Somebody asked if fluid bed roasters are better than drum roasters. If, again, going back to what is your goal in roasting? If your goal is to roast light and have a lot of flavor clarity, delicate flavors, then you probably would prefer an air roaster, whether it's a fluid bed or whether it's a machine like a Loring or an IMF. If you want some body in the coffee and you're going to roast on the darker side, then a drum roaster is definitely appropriate for you. It really just comes down to that. What is your preference for the end result in the cup? And that's not to say that a drum roaster can't produce high clarity, beautiful, delicate, light coffee, because it definitely can. It's just that air roasters tend to make that a little bit easier, and drum roasters tend to automatically give you a little bit more body at the expense of some clarity. So there's a question of whether you always need two airflow settings during your roast. You don't need it. You can definitely get away with one airflow setting that's about a 45-degree pull on the lighter test. Using two settings, one where there's just barely any draw, and then another where there's a 45-degree pull, tends to be a little bit better because it allows you to use a lower peak gas setting, and that will help keep the drum surface a little bit cooler, which is a positive for most people. I'm sorry, what was the second question, Christina? Okay, so someone asked, what if there is noticeable smoke despite passing the lighter test? This is where you need some judgment. I would recommend cupping several roasts, and when you break the crust during the cupping, see if the coffee seems smoky or not. That's the best time to judge whether you had enough airflow. It should be okay, and it's important to be able to discriminate between, if you're roasting pretty dark, smoke from inadequate airflow and just simple roasty flavors. It takes a little practice to discriminate between the two. But if you break the crust and it doesn't seem smoky, you're fine. If you break the crust and it seems smoky, I would say just go a little bit higher in airflow just to be safe. Oh, okay, I'm sorry, I misunderstood the question. So at the end of the roast, the airflow is so high that it's pulling out the lighter during the lighter test. Then you definitely have higher airflow than you need. When it comes to very large machines, like let's say 60 kilos and larger, the cigarette lighter test tends to pull a little bit harder, tends to be kind of a horizontal pull more than a 45-degree pull. With machines smaller than 60 degrees, you can usually achieve a 45-degree pull pretty easily. Again, really what it comes down to is you should be using the lowest airflow setting that doesn't give you smoky coffee. And it's helpful to find that line. There's going to be some smoke when you open the door, especially if you're roasting anywhere beyond, say, a light third wave type of roast. So don't worry about that too much if there's some smoke. I'm much more worried about smoky flavor in the cup than I am smoke coming out when you open the door. The old UG Probots, which did not have an adjustable fan, but had those 3 settings with that wheel, which had the famous espresso setting for the airflow. Those machines used much lower airflow than the current modern Probots offer, even at the lowest setting on the new machines. And those old machines tended to make really nice coffee. And I really do think that the key to those machines was that their airflow setting was quite low. And there would always be smoke when you opened the door of those machines, but the coffee didn't taste smoky. Not necessarily, anyway. But you had to roast quite dark to start getting like a smoky effect in the coffee with those machines. So I think that what's in the cup is obviously most important, and the airflow, the lighter test is there just as a guide. But ultimately, I care most that the cup is not smoky, and in almost every situation, if you have about a 45-degree pull or more than that, you won't get smoke in the cup. So if you have an indirectly heated machine, which means you might have a drum roaster, but the heat source might not be under the drum, it might be pretty far from the drum, or if you have an air roaster of some kind, like a fluid bed, IMF, Loring. Well, Loring does not allow you to control the airflow settings, so we'll leave that aside. But in any machine other than a classic drum roaster, we're not as concerned about the precise airflow level, in the sense that we're not trying to manage the drum surface temperature. So the short answer is that the airflow isn't a concern as long as it's high enough to remove the smoke and chaff. In a machine that has inlet temperature control, in other words, instead of managing the gas with, say, 80% gas, 70%, 60% gas, but instead there are machines, like, let's say IMF and Civets, that you can control the inlet temperature directly. So you can tell it, give me air that's 360 degrees Celsius, 340 degrees Celsius. So that is the temperature of the air entering the roasting chamber. In those machines, increasing airflow will accelerate heat transfer. So in those machines, the heat transfer is temperature times airflow. And this is because when you increase the airflow, the burner will work harder in those machines to maintain a certain inlet temperature. So the bottom line is that we're only worried about minimizing the airflow to the lowest acceptable level in classic drum roasters. In other types of machines, there's a lot more freedom to use different airflow settings. Are we all caught up there? Okay, fantastic. If you have a damper on your machine, The damper will affect the pressure in the drum. So if you have a manometer measuring air pressure, you will see really big changes in the pressure when you change the damper settings. But the damper will not affect the airflow level that much. It'll have a minor effect on airflow. Most of these dampers are not so user-friendly. They might be difficult to reset to the same exact position every time. They might be hot to the touch. They might have a little screw that you have to loosen in order to move it. My general recommendation with these dampers is to set it and forget it. Just find a setting that works well and just leave it there. If you have an adjustable fan, just focus on that. And if you don't have an adjustable fan, just find a damper setting that's working well for you and don't adjust it in the middle of roasts. Okay, there's a question about adjusting drum RPM and airflow levels to get cleaner coffee in an air roaster. I don't think that that dynamic exists. Yeah, I'll just leave it at that. I don't think that either in an air roaster that drum RPM or airflow should be used in an attempt to adjust flavor, in the sense that you can succeed with identical results with a variety of airflow and drum RPM settings, assuming that you're in reasonable ranges for both. So I don't know how else to answer that question. Oh, what is a damper? So a damper is a little sliding gate that will close off part of the chimney or duct in the exhaust of the roaster. So in this case, that diagonal piece that you see there, if you were to push it down, it will close off some of the open area within the exhaust pipe. So it's meant to decrease the amount of airflow, but again, it has a relatively small effect because the fan is still spinning at the same speed and working just as hard. And what happens when you close off the damper is you create a little more pressure in the drum relative to the airflow, but the airflow level changes very slightly. Are we caught up on questions? Okay. So this is an image of a roast done in a Diedrich IR12, and the two vertical red lines represent changes in airflow. So you'll notice that after the first airflow change, the bean temperature ROR, which is that blue line that looks like a bit of a mountain, a bit skewed, the bean temperature ROR gets a bit flat for about 30 seconds or a minute after that airflow change. And that volatile yellowish orange curve spikes. That curve is the environmental temperature rate of rise. So the environmental temperature curve, which is the top yellow/orange curve, that is the temperature of air that is leaving the roasting chamber. It is not a temperature that the beans experience during roasting. It is a mix of two types of air that has passed through the beans and lost some heat to the beans, and air that has left the burner and potentially bypassed the pile of beans and just left the roasting chamber while still very hot. So it's a blend of these two airs. It's not a valid roasting number in the sense that this is not a temperature that the beans ever experience. The environmental temperature, ROR, is the rate of change of the environmental temperature. And you'll notice that when you increase airflow, that ETROR spikes temporarily. So what's happening there is the burner is at a certain temperature, you increase the airflow, and you're taking that hot air and you're flushing it through the drum faster. So you have this temporary acceleration in that hot air, but then you've effectively spent that saved heat. It's a little bit like a bank account where you had a balance and you took some out. So now you spent some of that saved money. So you spend some of that saved heat. So eventually the BT ROR and ET ROR go back to their trend line. The important thing here is to say, if someone were to come to you and say, what happens when you increase airflow in roasting? The answer is, it depends on how hot the burner is at the time of the airflow change. So that first airflow change saw a big spike in the environmental temperature ROR and a little bit of stickiness in the drop of the BT ROR. That second airflow change, the burner was much cooler at that point, so we saw a much smaller effect from that increase in airflow. And if you were to increase the airflow at the very end of a roast where the gas is off or at a very, very low setting, you might see the increase in the airflow actually decelerate the roast or make the bean temperature ROR drop rather than stay a bit higher. So there is no simple answer to what happens when you increase airflow. The answer is it depends on the burner temperature relative to the temperature of the air in the roasting chamber. Okay, just making sure there's no questions before I move forward. Yeah, okay. Yeah, so there's a little bit of a delay, and so sometimes we'll have to go back to a previous slide to cover a question. So thankfully, this slide with the probe placement has become less and less important over the years. Many years ago, most manufacturers put the bean temperature probe quite near the middle of the drum, and the probes really didn't do a good job of measuring bean surface temperature unless you were doing a full batch. But some of us have been badgering manufacturers for many years, asking them to move the probes much lower, closer to the drum edge, so that if we were doing much smaller batches, we would still get good bean temperature readings. And so if the bean probe is in the optimal location, so in this case, this drum is spinning anti-clockwise or counterclockwise. If you put the probe somewhere in that pink swatch, you'll get very good bean temperature readings, even at very small batches, let's say down to about 20% of machine capacity. If the probe is much closer to the center of the drum, you might need to do quite a large batch to get high quality bean temperature readings, because otherwise the probe is mostly touching air and not really reading bean temperature. When it comes to the environmental temperature probe, it almost doesn't matter where you put it as long as the probe is not too close to the beans. So you could put the probe in the sides of the loading funnel. You could put it in place of one of the bolts that's holding on the loading funnel. You could even put it back near the fan, the exhaust fan, and we might call that the exhaust temperature reading. Because, as we discussed, this reading is not something the beans experience during the roast, it's not that important of a data point, but the ROR of the ET probe has some uses, as we'll see throughout the class. So it's not very important where that ET probe is, and for example, because it's not important, if you were to see something like this curve where the environmental temperature at the end of the roast is at the same level as the bean temperature or maybe even lower, that's not significant. It doesn't mean anything. It doesn't mean that the air temperature in the roasting chamber is lower than the bean temperature. So just keep that in mind. It's not very important if the two lines cross at any point. So someone asked if there's any pros or cons to using very high airflow during the last 10 seconds of a roast. No, the answer is not really. Something to realize about the very end of a roast is that whatever's happening at the very end will affect the surface of the beans, but there won't be enough time for any effect on the surface to penetrate the beans very deeply. So, for instance, you won't really be affecting inner bean development much if you were to make a big change at the end of a roast. If the roast begins to accelerate, in other words, if the bean temperature ROR were to rise quickly at the end of a roast, we often call this a flick. then you run the risk of the coffee tasting slightly roastier because the outside of the bean might be getting some damage from a very hot drum or from the temperature rising, and you won't see extra inner bean development from a flick because there's just not enough time for that applied heat to the outside of the bean making its way towards the center of the bean. It's a little bit like cooking a piece of meat in the oven and then finishing it off under the grill where you sear the outside of the meat, where you don't expect that to affect how well cooked the meat is at the center of the piece of meat. You'll expect it to just give a little blackening or burning of the outside of the meat and not have much effect on the inside. When it comes to probes, smaller tends to be better. If your probe diameter is 1 to 3 millimeters, maybe 4 millimeters, that's good. If it's larger, the probe will have what's called thermal lag. So the probe has its own mass, and because of that, the probe will always be catching up a little bit to the bean temperature. So in a curve like this, when you see the bean temperature drop for the first minute and a half and then reach what we call the turning point and begin to rise, of course that first minute and a half of readings is false, because the beans don't start hot and get cooler. The beans start around room temperature and just get hotter. So what's happening there is when you charge the batch, the probe was hot. It took the probe about a minute and a half to shed enough of that heat to finally match the temperature of the beans and then begin rising with the bean temperature. So the turning point of the roast is not real. It never happened in real life. The beans did not experience that. It has no relevance whatsoever to a roast in terms of flavor or roast development, because it's just an artifact of the probe cooling. And if you were to change the probe but do everything else the same, the turning point would happen at a different time and a different temperature. So thinner probes have a lot less lag, and the turning point will be much lower and sooner. And thicker probes will have a lot of lag, and all of your data will be lagging a little bit depending on the mass of the probe. Yes, Christina? So there's a question about using infrared probes. They can work. So there's a machine out there called the Bullet, which is a 1 kilo home roaster. And the Bullet has an infrared probe. And anyone here who's used the Bullet will know that the infrared reading is much more volatile than the thermocouple reading. And what Aleo, the company behind the Bullet, realized was they needed many infrared probe data points in order to smooth out the data. So that one infrared probe was giving a lot of volatility. So on the second machine that they built, their R2 machine, they put in 128 different infrared probes or sensors, and they fed the data from those 128 sensors into software that then averaged their readings to provide a much more stable bean temperature reading. So infrared probes can work, but you're going to need a lot more than one data point in order to take away the volatility of the reading. Okay, so when you warm up any roasting machine, it's going to be important to bring the machine's temperature a little above your typical roasting temperatures and take advantage of what's called the heat sink effect. So we're effectively going to make the machine hotter, faster, in order to get to what I would call the equilibrium thermal energy that you'll want to be at before each batch during the day. So what I mean by this is, if you usually, let's say, charge and end batches at something like 200 to 205 Celsius, or about 400 to 410 Fahrenheit, you would want to have the empty machine running at a bean temperature reading a little bit above your charge and end temperatures for quite a while in order to get the machine hot enough. Because if you were to just say, okay, I'm going to bring the machine up to 400 degrees Fahrenheit, I'm going to idle for a half hour, and then I'm going to charge, in almost every machine in the world, the machine will not be hot enough after such a warm-up. You have to go a little past your usual charge / end temperature to get the machine hot enough. So I would recommend, depending on the size of your machine, probably being about 20 to 25 degrees Celsius above your average charge or end temperature, and about 40 to 50 degrees Fahrenheit. Now, if the machine's very small, let's say 1 kilo machine, you might want to be at that high idle temperature for about 20 minutes. If you have a larger machine, let's say like 15 kilo, you might want to be at about 45 minutes. And if you have a very large machine, like let's say 60 kilos plus, you'll probably need to be at that high idle for a little more than 1 hour. Once you have finished that high idle phase, you'll want to go to what I call the low idle, which should be just above your average of your charge and end temperature. So let's say, in this case, about 210 Celsius, maybe 415 Fahrenheit for about 10 minutes. And then after that, perform between batch protocol and charge. Please ignore where it says half BPP here. I think that's not necessary. We'll just do a regular BPP, which we'll talk about shortly. So what this means, sorry if this sounds a little complicated, but sometimes a graph helps. So in the first couple of minutes of this warm-up curve here, the temperatures are rising up to the high idle. Then we are at the high idle for quite a long time, almost an hour here. And then we're moving to the low idle for about 10 minutes, and then you don't see the BBP here because the person who did this stopped recording the warm-up at the time of the BBP. And then, so we have our typical BBP, and then we charge. If you practice this procedure and make small adjustments every time you roast, you will eventually settle on a warm-up that will give you a precise first batch that will be totally, exactly identical to how the curve would look on the last batch of the day if you use the same settings. That's what I would consider a very successful warm-up. So most of the time, this is what I see when I begin working with a new roaster, that the first batch is a little sluggish compared to the second batch. And that's an indicator that the warm-up was not hot enough. So if the first batch is too slow, then that means make the high idle hotter or longer, usually hotter, but perhaps a little longer too. And if the first batch is about right, but the turning point is too low or too high, if it's too low, then increase the low idle a little bit hotter. And if it's too high, then decrease the low idle. So if you think of the high idle as controlling the total roast time, and think of the low idle as controlling the turning point, then you have two levers that you can adjust to get your warm-up right on target. And once you've done that, then you can just make small adjustments seasonally. Let's say you might need a little bit more time in your high idle in winter than summer, etc. But you should get to the point where you're very confident that your first batch will be right on target, just like any other batch of the day. The only machine this does not apply to is the Loring, because the Loring does not let you idle at a certain temperature. With the Loring, it asks you to choose a minimum and maximum return air temperature when the machine is empty, and the machine will bounce between those two minimum and maximum temperature settings when the machine is empty. So we'll discuss the Loring specifically a little bit later. Okay, when planning a roast day, most of us are familiar with the math involved in converting roasted coffee needs to green coffee quantities. So for instance, if you needed 10 kilograms of roasted coffee and your weight loss was 14%, you would divide 10 kilos by 0.86, which is the roasted weight percent. And then it would tell you, oh, you need 11.63 kilograms of green coffee to end up at 10 kilos of roasted coffee. I won't go too deep into this. I'll just leave this as a reference for anyone who wants a guide that they can refer to when doing these calculations. So this may surprise most roasters, but roast time is not very important. Now, there are exceptions to this, but when it comes to air roasting, I am certain that I could present to you a 7-minute roast and a 14-minute roast that have identical color, identical weight loss, and that no one could taste both blindly and have any confidence which cup was roasted faster and which cup was roasted slower. So what this means is that the flavor chemistry is not very dependent on roast time. There are limits to this. I mean, I think that if you roast faster than 4 minutes, that the flavor chemistry changes a bit in an obvious way. And you can roast quite slow and have quite a nice result as well. But with an air roaster, this is true. With a drum roaster, time matters, but not because of chemical reactions during roasting. Time matters because when you roast faster in a drum roaster, you need a larger flame to roast faster, and that larger flame is going to make the drum surface hotter, and that is going to give you more conduction. So if you roast faster in a drum roaster, you are likely to taste the roasty or tarry or heavy or blunter flavors from the conduction. So it's important with drum roasters to not roast too fast. But in an air roaster, you have quite a bit of flexibility in how fast you want to roast. And the speed of the roast will not affect the flavor noticeably. If you want to affect inner bean development, of course, the easiest way to increase inner bean development is just roast darker. Now, if you say, I don't want to roast darker, but I want to get a little bit more inner bean development, there's 2 levers you can pull to influence inner bean development. One is to reach first crack at a higher ROR. That will give you a little bit more pressure within the bean, and it tends to help develop the inside of the bean a bit more. The other option is to increase the development time. So if you were to, development time is the time from the beginning of first crack to the end of the roast. So if you were to use a lower ROR for longer at the end of a roast, you might have a smidge more development than if you used a higher ROR for a short period of time. We'll touch upon this again at some point here. I would like you to think of charge temperature as not being very important. To me, it is really nothing more than the last step of a between batch protocol. And the between batch protocol is much more important than the nominal charge temperature. So I want to give you 2 examples to illustrate this. Imagine you had a situation where you dropped a batch, you turned off the gas, you waited a few minutes, the bean temperature probe reading of the empty machine reaches, let's say 150 Celsius, you turn the gas on, a minute later you get to 200 Celsius and you charge. Now, in the second scenario, you leave the gas on at a low setting as you drop the batch. The 3 minutes later, the temperature rises to 250 Celsius, and then you turn off the gas, and then a minute later it drops to 200 Celsius and you charge. In both cases, you have a charge temperature of 200 degrees Celsius, but in the second case, the drum is much hotter than in the first case because the flame was on the empty drum for quite a bit longer during that second example. So what matters when you charge is how hot is the drum surface, not what is the actual charge temperature, because the bean probe that you're relying on to tell you the charge temperature is just reading air, which has very little mass. And what we really care about is the drum surface temperature. That's not to say you shouldn't use a consistent charge temperature. It's just to say that you have quite a bit of flexibility when you choose your charge temperature, and the actual number is not very important. Just pick one that's working for you, and I'll show you how to choose it, and then just stick with it, and it'll be fine. Any questions, Christina? Okay. Mm-hmm. Right. Okay. Okay. So, for what it's worth, the percent capacity here, they're not dependent on roaster size. This is just, regardless of the machine you're using, if you were at, say, 50 or 60% capacity, you might choose a charge temperature of about 390 to 390. It's just an example, and again, the actual numbers are not that critical. And when we talk about how to create a between batch protocol shortly, it'll make a little bit more sense. When it comes to going back to roast time, it's also not very machine dependent. If you have a classic drum roaster, regardless of the machine, regardless of the batch size, you probably want to stick to roast times of about 12, 13, 14 minutes in order to make sure that the drum surface is not too hot. You can get good results with faster roasts, but the faster you go, the more risk you are taking that you will taste some side effects of conduction and the drum surface being too hot. So someone asked about if you are what's called omni-roasting, meaning that you're using the same roast for espresso and filter, is it better to have high temperature short time or low temperature long time? It doesn't matter if you're omni-roasting, so to speak, or filter or espresso, none of that really matters. What matters is if you're using a drum roaster, don't roast fast enough to have the drum hot enough to taste conduction. So that generally means sticking in that 12-minute range or so to be on the safe side. Now, if you say, let me backtrack here. It's a little tricky to talk about because it might be that what I think of as an espresso roast is the same as what you think of as a filter roast. In other words, there is no universal definition of what is filter, what is espresso, what is dark, what is light. So it's kind of impossible to just assume you know what someone means when they say espresso, filter, or omni roast. The better question is, what are you trying to achieve? If you are trying to achieve optimal flavor clarity, roast really slow in a drum roaster or use an air roaster. If you are trying to achieve heavy body and you're not very concerned about flavor clarity, then use a drum roaster and don't worry as much about how fast or slow the roast is. So, because there really is no definition for filter espresso or omni roast. I know that seems a bit crazy, but that's where we're at as an industry. And so anyway, that's the best I can do on that. Are we pretty much caught up? Okay, yeah. There's been a few questions about particular machines and optimizing them, and let's cover those once the class is over. What I will do is I will lock the discussion we've had so far, and people can create new posts about new topics, and then I'm happy to dive into machine-specific questions because I want to make sure that what is in the 3-hour presentation applies to everyone. And then we have that discussion group for the next 2 weeks to go as deep as you want to go into particular machines or strategies. Okay. When should you drop a batch? Now, the short answer is the best indicator of when to drop a batch is probably development time in almost all situations. Most roasters use bean temperature to decide when to drop a batch, and it's perfectly fine to use bean temperature if your curves are very consistent. If your curves are not that consistent, then you might want to focus on development time, or you might want to focus on a combination of all of these things. So let me give you an example. Let's say you are roasting 10 kilo batches in general. You have a 60 kilo bag of coffee, and on your last batch from that bag, there isn't 10 kilos of beans left in the bag because maybe the importer was stabbing it for samples or such. And let's say there's only 7 kilos in that bag. And you say, well, I don't have a 7 kilo profile, but I will do my best with it. I'll just take my best guess at the right settings to use. And it turns out you're roasting way too fast. So you say, okay, I'm roasting really fast. I don't know when to drop the coffee because my bean temperature reading is no longer reliable. The reason it's no longer reliable is that your bean probe isn't just reading bean surface temperature, it's being influenced by the temperature of the air surrounding the beans and surrounding the probe. And if you're roasting a lot faster, the air temperature in the machine might be a bit hotter, so it's going to influence the probe reading. And if you're used to dropping at, say, 410 Fahrenheit on the bean probe, that might be a wildly different color now that you're roasting really fast with a smaller batch size. In that case, you might choose to rely on looking at the beans and just going by sight, but I would say it's very difficult to tell all the different necessary important shades of brown by just looking at the beans. That's very challenging. Even after doing this for 30 years, it's very challenging. You might say something like, well, I'm used to dropping my batches just as first crack is ending or almost ending. So you could consider where you are in the crack cycle. You could look at the bean temperature, but again, you can't necessarily assume that the exact usual ending bean temperature is correct. And you could look at the development time ratio or the development time, or you could look at a combination of these things. So if you are flying blind in that situation, you might want to consider all these factors and give them each a little bit of weight. If you are in a standard situation where your curves are very consistent, then you can fall back on using either bean temperature or development time to decide when to drop batches. And if you are what I call off curve, so you have a reference curve, you're a little bit off for some reason, something's inconsistent, then I would say focus on development time exclusively to decide when to drop a batch if you're just a little bit off curve. At some low gas setting, and then make that your charge temperature. So we're finding the bottoming temperature by seeing where we're at with 4 minutes of gas being off, and we're finding the charge temperature by using a low gas setting, waiting about 60 seconds and saying, okay, I'm usually at about this temperature after 60 seconds. So the idea here is that graphically, what you can see here is when the door is open, the bean temperature looks like it's dropping rapidly. When you close the door, the bean temperature bounces or rises. And all that is when the door is open, room temperature air is passing by the probe and cooling it quite quickly. Once you close the door, the probe is back in the hot roasting environment and the probe temperature rises again. Then the probe slowly cools for 2 or 3 minutes, right? And once you're at roughly 4 minutes and you're at your chosen bottoming temperature, then you'll turn on the gas. And what you can notice here is that we reach the bottoming temperature at a slightly different amount of time each batch. And that is the between batch protocol doing its job. So for instance, there's a little bluish purple curve that's the very last curve to reach the bottoming temperature. And that curve reaches it last and rises most quickly. So what that means is the machine was a little bit hotter than usual during that BBP, so it took longer to reach the bottoming temperature, and then the machine had the gas off for more time than any of the other batches, and the gas on for the least time. And by having that round trip of cooling and then heating, we got the machine back to exactly the same thermal energy level. So the idea here is you're spending about 4 minutes cooling and about 1 minute heating, and having both of those, the cooling and then the heating, helps to reset the drum temperature. The idea is that this is a hack, okay? We don't know the surface temperature of the drum. There's no easy way for us to know the surface temperature of a moving drum. But through experience on a lot of machines, I realized that if we cool and then heat, we can hack it so that the drum temperature settles back at the same temperature when we're ready to charge every single time. About 4 minutes to a bottoming and 1 minute to charge is about as fast as you can go in general. If you try to go faster in your between batch protocol, it won't always work because the metal temperature can only change so quickly. Go ahead, Christina. Sorry. Okay. So when it comes to airflow during your BBP, I would recommend whatever airflow level you're using in the second half of your roasts, keep that airflow level during the BBP. If you are using 2 airflow levels during your roast batches, switch to the lower airflow setting right as you reach the bottoming temperature and after you turn on the gas. So again, if you're roasting with, let's say, 40% airflow at the beginning of a roast and about halfway through you're switching to 70%, stay on that 70 throughout the BBP. After you turn on the gas at the bottoming temperature, then go back to the 40% air. And so then when you charge, you'll already be at your charge airflow. That's pretty much optimal. If you just use one airflow setting through your roast, that one airflow setting is going to be perfectly fine for your between batch protocol. Something to remember is that, again, this is a hack. The bean probe reading is not the same as the drum temperature. And a lot of people get confused because they see that their bean temperature reading doesn't drop much during the BBP, and maybe somebody else's drops a lot more. So people get confused because they think that their machine is holding on to heat a lot more than some other machine is, but that's not necessarily the case. It could just be an artifact of where the probe is located and how much airflow there is where the probe is. And again, this BBP is just a hack. It's not indicating the drum temperature, but it is a way of manipulating the drum temperature. What's the question on the previous slide? I'm not sure I follow that. Do you think they mean like reading a roast curve to see how a coffee tastes? Oh, okay. When it comes to this idea of when to drop a batch, we haven't talked about quality control and roast development yet, but what's most important at the end of the day is what is the color of the coffee. Color is by far the best correlate to flavor. And what I'll recommend later in the class is tracking the weight loss and the color, and of course cupping the coffee ultimately to decide how to adjust things. But bear with me, and we'll cover that a little bit later and hopefully answer the question. Okay. There are a few situations that make it challenging to use this between batch protocol. A lot of people have a chimney where there's a hot chimney and there's a chimney for the cooling bin. And if those two chimneys merge into one before leaving the building, then there's a chance that that will get in the way of a successful short between batch protocol, because the cooling fan in roasters tends to be about 3 or 4 times more powerful than the roasting fan. And when the cooling fan is on, if there's a merged chimney, the roasting drum will get choked of airflow. The airflow going through the drum will get blocked in the chimney by the cooling air. That can cause that can prevent the drum from cooling adequately because there needs to be air passing through the drum to help it cool. The more recent Diedrich machines, ever since about 2017 or so, they have these heat exchange rods that run along the side of the drum. And between the insulation and the heat exchange rods and the fact that there's only one fan, and when you shift to the cooling bin setting, there's not much air going through the drum, all those factors add up to it's very difficult to cool those machines between batches. And if anyone has a Diedrich IR machine built after 2017, let me know after the class. Write a post about it, and I'll give you a special BBP hack just for those machines. And then there's occasionally a machine that has some automation or control system that doesn't let you control the machine as you wish when it's empty. So for example, the Loring, like I said, has you can't idle, you can't just turn the gas off completely. You have to choose a minimum and maximum return air temperature and manage the machine that way during the between batch protocol, which we'll talk about the Loring BBP shortly. Okay. Ideally, it would be great if you only roast one, maybe two batch sizes per day. When you're trying to roast too many batch sizes, things get complicated quickly, and your chance of mastering multiple batch sizes and all of their between batch protocols goes down a lot if you choose too many batch sizes. If, for example, you have a 12 kilo machine and you want to switch from a 5 kilo batch to a 10 kilo batch, each batch size needs its own between batch protocol. So the temperatures are going to be a little bit higher during the BBP, during the 10 kilo batches than during the 5 kilo batches. But also, when you do your last 5 kilo batch, right before your first 10 kilo batch, ideally you'll use something called a transitional BBP. So during 10 kilo batches, the machine stays a lot hotter than it does during 5 kilo batches. So to make the first 10 kilo batch run according to plan, you need to idle the empty machine a bit hotter than your charge or end temperature for quite a while before going into your BBP for your first 10 kilo batch. So I would recommend starting by idling about 10 degrees Celsius or 20 Fahrenheit above your average of your charge and end temperatures for about 8 minutes. Then do your 10 kilo BBP, then charge your first 10 kilo batch. If you were going from larger batches to small, you might turn the gas off for about 8 minutes and then turn it onto a higher setting than you would usually use during your BBP so that you rise up to your charge in about a minute. This takes a lot of practice. This is very advanced. It's going to take a lot of practice, and if you stick with only those two batch sizes and practice this transitional BBP, eventually you'll master it so that the first batch of the different batch size is on target. But again, this takes some practice to really get right. Any questions? Okay. So it's tempting to want to play with a lot of variables during roasting simply because you have the options. But I'd like to recommend that you try to simplify things by taking some variables and turn them into fixed settings. So, for example, if you're doing all different coffees, but 10 kilos every batch, they all should have the same between batch protocol. There's no need to change between batch protocol for different types of coffee. Likewise, the charge temperature, since it is nothing more than the last step of your BBP, that should also not change. So once you pick a batch size, you pick your between batch protocol, which includes your charge temperature, and that does not change for different coffees. Likewise, if you tend to use a certain airflow pattern for your 10 kilo batches, just keep that same airflow pattern for all coffees. There's no need to change airflow settings for different coffees. So once you've done all of that, and presumably you are using one drum RPM setting all the time for a certain machine. Now, all of those things are effectively determined, and now when you switch coffees, all you have to worry about is your gas settings. The level you're using in the second half of your roasts, keep that airflow level during the BBP. If you are using 2 airflow levels during your roast batches, switch to the lower airflow setting right as you reach the bottoming temperature and after you turn on the gas. So again, if you're roasting with, let's say, 40% airflow at the beginning of a roast and about halfway through you're switching to 70%, stay on that 70 throughout the BBP. After you turn on the gas at the bottoming temperature, then go back to the 40% air. And so then when you charge, you'll already be at your charge airflow. That's pretty much optimal. If you just use one airflow setting through your roast, that one airflow setting is going to be perfectly fine for your between batch protocol. Something to remember is that, again, this is a hack. The bean probe reading is not the same as the drum temperature. And a lot of people get confused because they see that their bean temperature reading doesn't drop much during the BBP, and maybe somebody else's drops a lot more. So people get confused because they think that their machine is holding on to heat a lot more than some other machine is, but that's not necessarily the case. It could just be an artifact of where the probe is located and how much airflow there is where the probe is. And again, this BBP is just a hack. It's not indicating the drum temperature, but it is a way of manipulating the drum temperature. What's the question in the previous slide? I'm not sure I follow that.
She paused it again.
Do you think they mean like reading a roast curve to see how a coffee tastes? Oh, okay. When it comes to this idea of when to drop a batch, we haven't talked about quality control and roast development yet, but what's most important at the end of the day is what is the color of the coffee. Color is by far the best correlate to flavor. And what I'll recommend later in the class is tracking the weight loss and the color, and of course cupping the coffee ultimately to decide how to adjust things. But bear with me, and we'll cover that a little bit later and hopefully answer the question. Okay. There are a few situations that make it challenging to use this between batch protocol. A lot of people have a chimney where there's a hot chimney and there's a chimney for the cooling bin. And if those two chimneys merge into one before leaving the building, then there's a chance that that will get in the way of a successful short between batch protocol, because the cooling fan in roasters tends to be about 3 or 4 times more powerful than the roasting fan. And when the cooling fan is on, if there's a merged chimney, the roasting drum will get choked of airflow. The airflow going through the drum will get blocked in the chimney by the cooling air. That can prevent the drum from cooling adequately, because there needs to be air passing through the drum to help it cool. The more recent Diedrich machines, ever since about 2017 or so, they have these heat exchange rods that run along the side of the drum. And between the insulation and the heat exchange rods and the fact that there's only one fan, and when you shift to the cooling bin setting, there's not much air going through the drum, all those factors add up to it's very difficult to cool those machines between batches. And if anyone has a Diedrich IR machine built after 2017, let me know after the class, write a post about it, and I'll give you a special BBP hack just for those machines. And then there's occasionally a machine that has some automation or control system that doesn't let you control the machine as you wish when it's empty. So for example, the Loring, like I said, has you can't idle, you can't just turn the gas off completely. You have to choose a minimum and maximum return air temperature and manage the machine that way during the between batch protocol, which we'll talk about the Loring BBP shortly. Okay. Ideally, it would be great if you only roast 1, maybe 2 batch sizes per day. When you're trying to roast too many batch sizes, things get complicated quickly, and your chance of mastering multiple batch sizes and all of their between batch protocols goes down a lot if you choose too many batch sizes.
Pick it up lah.
If, for example, you have a 12 kilo machine and you want to switch from a 5 kilo batch to a 10 kilo batch, each batch size needs its own between batch protocol. So the temperatures are going to be a little bit higher during the BBP, during the 10 kilo batches than during the 5 kilo batches. But also, when you do your last 5 kilo batch, right before your first 10 kilo batch, ideally you'll use something called a transitional BBP. So during 10 kilo batches, the machine stays a lot hotter than it does during 5 kilo batches. So to make the first 10 kilo batch run according to plan, you need to idle the empty machine a bit hotter than your charge or end temperature for quite a while before going into your BBP for your first 10 kilo batch. So I would recommend starting by idling about 10 degrees Celsius or 20 Fahrenheit above your average of your charge and end temperatures for about 8 minutes. Then do your 10 kilo BBP, then charge your first 10 kilo batch. If you were going from larger batches to small, you might turn the gas off for about 8 minutes and then turn it onto a higher setting than you would usually use during your BBP so that you rise up to your charge in about a minute. This takes a lot of practice. This is very advanced. It's going to take a lot of practice, and if you stick with only those 2 batch sizes and practice this transitional BBP, eventually you'll master it so that the first batch of the different batch size is on target. But again, this takes some practice to really get right. Any questions? Okay. So it's tempting to want to play with a lot of variables during roasting simply because you have the options. But I'd like to recommend that you try to simplify things by taking some variables and turn them into fixed settings. So, for example, if you're doing all different coffees, but 10 kilos every batch, they all should have the same between batch protocol. There's no need to change between batch protocol for different types of coffee. Likewise, the charge temperature, since it is nothing more than the last step of your BBP, that should also not change. So once you pick a batch size, you pick your between batch protocol, which includes your charge temperature, and that does not change for different coffees. Likewise, if you tend to use a certain airflow pattern for your 10 kilo batches, just keep that same airflow pattern for all coffees. There's no need to change airflow settings for different coffees. So once you've done all of that, and presumably you are using one drum RPM setting all the time for a certain machine, now all of those things are effectively determined. And now when you switch coffees, all you have to worry about is your gas size. And this allows you to focus on just one variable during your roasting that gets adjusted differently for different coffees. So I think of the between batch protocol, the charge temperature, the airflow, the RPM as machine management. They have nothing to do with the coffee involved. It just has to do with the machine and the batch size and managing the big picture, and then adjusting things for individual coffees comes down to just adjusting the gas settings and nothing else. If you use this system, things will be quite easy. I'm not saying there's no other way to roast. I'm just saying this is the simplest way to roast, and you won't be giving up any potential quality or consistency by using this system, but you will be making it a lot easier than if you are trying to juggle lots of variables all the time. So this is my recommendation for the simplest possible roasting system. How much gas a given coffee requires, of course, is very dependent on batch size, but within a certain batch size. The most important factor is the size of the beans. Larger beans need more gas. The type of processing influences the gas settings needed. So washed coffees tend to require more heat input than naturals do. Honeys tend to be somewhat similar to washed or somewhat similar to naturals. There's kind of a spectrum of honeys. Moisture content is important. The more moisture the coffee has in the green, the more heat you are ultimately going to need to roast it, because higher moisture coffees will release more heat during roasting, will release more moisture during roasting. And the moisture that comes out of the beans creates this little field of vapor around the beans, and you will need more heat to burn off that vapor to then get the heat to the bean surfaces. Most people think density is very important when it comes to what settings to use, but that is not the case. I think part of the confusion over density is that most people think they are measuring density, but they are usually referring to something called bulk density. And if you were to say, take a container of a certain size, fill it with beans and weigh it, you might say something like, okay, this coffee is 900 grams and the container is a volume of 1 liter, and that's the density, 900 grams per liter. That is not density, that is bulk density. And bulk density is affected by how well the beans fit together. So the size and shape of the beans affect the bulk density. But the real density reading involves
去开床去
displacement.
睡觉，哥哥。
So
What are
if
you
you were
doing
to
here?
then fill that container with water, see how much water volume went into the container, and then figure out how much volume the beans actually displaced, then you could say, okay, 900 grams divided by that volume the beans actually take up, that is the real density reading. You can also get a machine that measures density. But when you look at the proper density reading, you will find that most specialty high-grown coffees don't vary that much in density. So let's say all the beans in your roastery might have a density range of about 20%. So that's not much. That's not gonna, little shifts in density are not going to change how much energy you need to roast the coffee. But if you think about it, bean size can vary tremendously. If you had a tiny mocha variety of bean and you had a Margogipe or a Pacamara, the large beans might be 500% larger than a small bean, right? So bean size can vary tremendously and have a huge impact on how much gas you need, but density, not so much. So the moral of the story is larger beans require a little bit more heat. Washed requires a little bit more heat than naturals. You don't have to worry about too much beyond there, and if you were to consider anything, it would be moisture content. It would have a small effect as well. Okay, so we're going to talk about managing first crack. So when
Quiet.
you are roasting, the cell structure of the beans is steadily getting weaker as you cook the beans and they get darker. At the same time, once the center of the beans reach boiling temperature, so let's say roughly 100 degrees Celsius, steam builds up within the beans. And because water changing to steam expands, it creates some pressure within the bean as that water vapor builds up. So you have a process where the cell structure is getting progressively weaker. The pressure within the beans is getting progressively greater.
Bottom.
And eventually you reach a tipping point where the cell structure is no longer strong enough to hold in the steam pressure. and the beans will fissure open and make a popping noise when they crack open, and they'll release a little puff of
This one or
steam.
the other one?
So that is the process of first crack, is this release of steam once the pressure is too great to be held in. And generally speaking, smaller beans roast a little faster than larger beans, so you can assume that early in first crack you've got a greater number of small beans popping, and later in first crack you've got some larger beans popping. And first crack tends to get louder and crescendo toward the middle of the crack, and then get quieter as the crack progresses. So when a lot of beans are simultaneously cracking open and releasing their cooler moisture, that is when the ROR might drop very quickly, or what we call a crash. The ROR drops because the moisture coming out of the beans is cooler than the bean surfaces, and that process of evaporative cooling slows down the heating of the surface of the beans. In the extreme, the surface of the beans might actually get cooler temporarily. You usually won't see that in your roasting data because your data is smoothed and averaged over a time period such as 15 or 30 seconds. But what is important is if a lot of beans are cracking in a short period of time, the ROR tends to drop very quickly. In and of itself, that's not that big of a deal, but if you are roasting to say a medium or darker roast level and the ROR has crashed quite low, then the only way to finish your roast and get to your desired color is to have a flick at the end. So the ROR is going to have to rise at some point. In a drum roaster, a flicking ROR tends to taste a little roastier on average than a controlled ROR curve. So let's see. Yeah, this isn't actually a flick, but okay, sorry. I thought I had that there, but I don't. If the ROR rises at the end of a roast, you might have a bit of roastiness. So it's helpful to manage the descent of the ROR during first crack. You might notice here that until about 12% DTR, it says high risk of crashing, do not lower gas. So when it comes to washed coffees, the best strategy is find a gas setting about 40 seconds before the crash. Find the highest gas setting that doesn't cause the ROR to go flat or rise, so the ROR will be dropping gently, and stay on that gas setting all the way until 12% DTR. Once you get to 12% DTR, drop the gas by about half, and then at 14 again by about half, and at 16 again by about half. This is because somewhere between 16 and 17% DTR, that's always where the ROR would flick. So the idea here is we are putting on the brakes at about 12, 14, and 16 DTR as a way of managing a potential flick. I see this a bit like driving a car where you see a red light 50 meters ahead of you. You don't wait 49 meters to slam on the brakes all at once, because if you don't time it well, you'll end up in the intersection and have a problem. But if you say, all right, at 50 meters, I'll tap the brakes. At 25, I'll tap the brakes again. At 10 meters out, I'll tap the brakes and I'll slow in a controlled way to a stop. That's what we're doing here. We're saying at about 12% DTR, we want to start lowering the gas to prevent a flick. And you can roast usually to a medium level with pretty good control and no flick. If you're roasting exceptionally dark, it becomes pretty difficult to avoid a flick. Again, in a drum roaster, flicks tend to create roasty flavors. In an air roaster, it's not as important, but a big flick can widen the spread between the inside and outside color. During first crack, what is happening in a sense is the spread between the outside color and inside color is shrinking as you go through the crack. And If you begin to flick, then the outside is getting darker much faster than the inside. And so you get a widening of your color spread. So if you're trying to develop the inside of the coffee, it helps to have a longer, slower ROR and development time in order to control the inner development of the beans. Any questions, Christina? Does the steam that releases during first crack increase the drum temperature? No. Oh, lower the drum temperature. Potentially, but probably insignificantly. The moisture coming out is going to have a big effect on the surfaces of the beans and the ability of the hot air to reach the beans. But I don't believe it has a significant effect on the surface temperature of the drum, since the drum is so heavy and so hot, it's not going to get affected much by a little bit of moisture. Any other related questions? So somebody asked if I recommend opening the air after first crack when roasting light. I don't. I tend to, so in a situation like this, say first crack is at 8:35, I would say I would want to make my last airflow change at least 2 minutes before first crack begins. While you can increase the airflow during first crack, I'll point out two problems with that. One is that smoke starts to develop slightly before first crack begins. So whatever airflow setting you require to expel the smoke efficiently, you should be at that setting well before first crack begins. And I can't see any real benefit to increasing the air during first crack, in the sense that you should already be at your highest setting to expel the smoke. The other thing is that there's a lot of dynamics shifting during first crack. You have big shifts in moisture release. You have potentially the ROR dropping a lot or rising a lot, and ideally you want to control that process. And changing the airflow, I think makes things a little bit complicated. I think a simpler system of one very low setting in the first half of a roast and a second higher setting about the middle of the roast is adequate for getting the job done in terms of heat transfer, controlling smoke, minimizing drum temperature, and there's no benefit to adding more complexity by adding more airflow settings. So can you do it? Yes, but I think it's adding a little bit of unnecessary complexity to the process. So the reason that the ROR rises is that once this moisture release is over, now the beans are very exposed, right? During first crack, there's this kind of force field of water vapor that the hot air has to burn off for the hot air to reach the bean surfaces. And once that moisture release stops, now it's very easy for the hot air to reach the bean surfaces, and the bean surface temperature will rise very quickly if you don't lower the gas settings adequately ahead of time. Okay, so there's two questions. One is, how do I predict first crack? And the other is, what if first crack doesn't seem to occur? So in most machines, if you turn on the environmental temperature ROR curve, you can see the beginning of first crack in the data. So you'll see some 1 or 2 or 3 quite large drops and rises in the ET ROR. And with a little bit of practice, where let's say you know that your first crack always happens somewhere between, let's say, 390 and 400 Fahrenheit. you might see a big up and down at about 370 something. You might see a big up and down at about 380 something. And then here, like in this case, the ETROR dropped and then rose very quickly at about 394. And since you know your first crack audibly always begins somewhere in the 390s, then you know that this one is the one that indicates first crack. And I think what's going on here is when the beans begin to release moisture at the beginning of first crack, that moisture deflects some of the hot air that is approaching the beans, and that deflects the heat out of the system without passing through the beans. So if you remember when we talked about how the environmental temperature is a combination of air that has passed through the beans and some air that went straight from the burner out the exhaust, this first crack moisture release is deflecting some of the air so that a little bit more of that very hot burner air leaves the roasting system without passing through the beans and getting cooler. So there's this temporary uptick in the environmental temperature, and that is the beginning of first crack. You can't really know when first crack will occur without having roasted some batches. You'll find most coffees crack at similar temperatures, and you can use the ETROR to be very precise about marking first crack. But let's say it's the first time you've ever roasted a coffee in a brand new machine, there's absolutely no way to know when first crack will occur until you've roasted some coffees. There are situations with some naturally processed coffees where if you are roasting light, your ROR is pretty low and you reach first crack, you may not actually hear first crack. Naturals tend to have much gentler cracks, much less pressure builds up within the bean. The moisture release is gentler and not as concentrated with naturals. So you may not hear it, and the ETROR signal may not be quite as obvious. But the short answer is just do your best. There's no guaranteed way to always know when first crack began in every single type of coffee. Rest assured, if you're having problems marking first crack, if you just decide, okay, I think first crack is somewhere around 390 most of the time, then just choose a temperature like 390, mark first crack at 390, and create a system based on that. Even though it's not going to be totally accurate, you can learn to manage things based on an assumed first crack point. It'll just take a little bit of practice to manage the timing of everything. But we can talk about specific coffee, specific machines in the discussion group over the next couple weeks if you have some coffees where you're having difficulty detecting first crack. So there's a bit of debate about if you are marking first crack audibly, do you mark it the very first time you hear a pop? Do you wait for a rolling crack? Assuming you can see the ETROR indicator of first crack, please use that. It is objective, consistent. It takes all the guesswork out of marking first crack. If you can't see this in your data, let me know, because I might be able to help you improve the quality of your data so that you can see it. And if all else fails and you have to go by audible, then just as soon as you hear more than one pop, go ahead and mark first crack. And that will be fine as long as you're consistently doing it at the second audible pop. That'll work close enough. We caught up? Okay. So I touched upon this in the last slide. When you're managing wash coffees, it's a good idea to find a gas setting that helps the ROR drop gently about 40 seconds before any potential crash, and then wait until about 12% ETR to begin lowering the gas aggressively. Ethiopian wash coffees tend to crash quite late, so you might have to shift all of these settings a bit later. I have no idea why Ethiopians crash so much later in the crack cycle than other coffees do, but it is pretty consistent. When managing naturals, you can more or less ignore where first crack occurred and just lower the gas in lots of smaller, more frequent increments. Still base those settings on bean temperatures, but maybe about 30 seconds apart. So you might, before first crack, you might drop the gas every, say, 4 degrees of bean temperature, and then maybe after first crack, 3, and then 2. But naturals tend to want to accelerate toward the end if you don't drop the gas sufficiently, and you might have surprisingly low gas settings for naturals during first crack. One note is that naturals tend to be a bit softer and more delicate. If you are using a classic drum roaster and the drum surface gets too hot, naturals will scorch or burn much more easily than wash coffees will. So whatever system you use for all of your coffees, as long as the system is not creating any burn marks or any roasty flavors in naturals, you should be safe for all coffees. But please do find that one system when it comes to roast time and between batch protocol, etc., that protects the naturals from any sort of burning, and you'll be in good shape. With air roasters, you don't have to worry about this the same way you do with drum roasters. It may be tempting with a classic drum roaster to increase the gas during first crack in order to make the curve look nicer and prevent a crash. I don't recommend this because this runs the risk of making the drum too hot, and you might be more likely to taste some roasty flavors, and this strategy would require exquisite timing in order to guarantee that there's no side effect that is tasteable in the cup. It's just not necessary. You should be able to get a good result without increasing the gas during first crack. I think it's just a bad idea, it's never necessary and always a bit of a risk. Okay, we'll talk a little bit about air roasting. Generally speaking, air roasting makes all of these a little bit easier or a little bit faster, so development tends to be a bit easier. You can roast a bit faster without worrying about drum surface temperature or anything like that. You don't really have to worry about scorching in air roasters. You might have some tipping in any machine. That has more to do with the delicacy of the germ at the end of the bean than it does with hot metal or such burning the beans. Tipping can happen in any machine with some beans. Your between batch protocol in an air roaster usually can be quite a bit faster than in a drum roaster. And as noted, air roasters tend to emphasize flavor clarity, but not body. Now, you can definitely succeed and have fantastic, high clarity, delicate coffee in a drum roaster. What this chart is meant to say simply is that these things are a little bit easier or a little bit faster in an air roaster. So ideally, if you have an air roaster, you would have one that allows inlet temperature control. So the inlet temperature is the temperature of the air that is entering the roasting chamber. So the Civets, the Brambati, the IMF, Vittoria, the Roost sample roaster, all of these machines offer inlet temperature control. So what this means is whether your ambient temperature in your roastery is freezing cold or swelteringly hot, what happens inside the roaster will not change at all. So if you have a drum roaster and you come into the roastery in the morning and it's quite cold, let's say it's 15 degrees Celsius or like 60 degrees Fahrenheit, and then you roast all day, and by the afternoon it's quite warm in the roastery. When you're using something like 80% gas on the valve setting, that's just telling you how open the gas valve is. If you are feeding much warmer air into the burner, then at 80%, the end result is slightly hotter air than you would have had in the early morning when the roastery was cold. So when you use inlet temperature control, you bypass this problem. And it doesn't matter if the ambient environment in the roastery is hot or cold, your roasts are going to stay perfectly consistent, which is really helpful. Definitely, it's an easier system to manage, and I assume that this is something that you're going to see more and more in the future. This is the Roost sample roaster with an inlet temperature control. Okay. All right, so going back to this chart, someone asked how to improve clarity in a drum roaster. The simple answer is roast slower and don't let the drum get too hot. So if you use the between batch protocol that I recommended earlier, and you keep your roasting time, let's say around 12-13 minutes, you will be able to get very good flavor clarity out of a drum roaster. If you start with a much hotter drum and or roast a lot faster than that, you will run some risk that the extra conduction will take away from that flavor clarity. So while I haven't said it explicitly, the whole system that I'm recommending in this course is designed to minimize conduction and make sure you get good clarity and delicate coffee. So all the little pieces that we're talking about in terms of roast time, minimizing airflow, between batch protocol, all of these things are geared toward managing the drum temperature and making sure things stay consistent. So in the Loring is one of the few air roasters that is managed by gas valve settings. And if you have a Loring or a similar machine, what I recommend is, much like in this red curve here, the gas settings rose during the first third or so of the roast. They stayed high for about the middle third, and then they went down during the last third. And I call this the pyramid. And the idea here is that the pyramid will help boost development in such a roaster. When you have a drum roaster, we typically begin with pretty high settings and just lower the gas settings from there, usually starting at about the middle of the roast. And the idea is that early in the roast, we have high gas settings and a lot of the applied heat is getting absorbed by the drum. Later in a roast, when we lower the gas settings, we are not applying as much heat, but then the drum begins to release some of its heat. So the drum is a bit of an equalizer. It's stealing a little bit of the heat from the high settings early in a roast, and it's adding a little bit of heat late in a roast when we use low settings. But with an air roaster, such as the Loring, you don't have the drum storing and then releasing heat. So you will need to apply more heat in the middle part of the roast to compensate. And usually I would say keep a very high gas setting during the middle third of the roast, and maybe begin lowering the gas about 10 or 15 degrees Celsius, or about 20 or 30 degrees Fahrenheit of bean temperature before first crack begins. So the idea here is that using higher gas settings in the middle of the roast will help make sure that your ROR is high enough entering first crack to ensure good development. So someone asked whether you can achieve full-bodied balanced coffee with an air roaster. The answer is it depends on your definition. If you want more body in any roaster, you need more development. And you might find that at a very light roast in an air roaster, you might find the body of the coffee to be inadequate, depending on your preferences. And the only way to increase body in an air roaster is to develop more or roast darker. So in a drum roaster, at any given development level, you'll have probably a little more body due to the potential conduction. In an air roaster, it'll always be a bit lower. So there is no magic roaster. In other words, there's no way to roast super light in an air roaster and get tons of body out of the coffee. You will have to roast a little bit darker or develop more on average to get more body. And it may or may not be the result that you want, but there's no way to have both this incredibly delicate light flavor and also heavy body. There will always be a trade-off, and you'll just have to decide where on the spectrum of clarity and body you prefer to be. So conduction increases body due to the surface damage of the beans by the hot drum, and it's effectively roasting the outer layer of the beans a little bit more. And so you're getting a little bit of this tarry, dark roast type flavor and feel, or mouthfeel, that comes with darker roasting. You may not see a dramatic change in color, but you'll just get this little bit of extra heavy, dense flavor in the cup due to the surface damage of the beans. Okay, moving forward. So if you have a Loring, if you look at the double-sided arrow on the left, the top of the arrow is the maximum return air setting, and the bottom of the arrow is the minimum. And the machine will, when the machine is empty, it'll simply bounce between the maximum and minimum. And you can conceivably do this once, where the machine hits the maximum, cools down to the minimum, and then begins to rise again. Or you could do it twice. My recommendation with the Loring is set the min and max about 50 degrees Celsius or about 90-something degrees Fahrenheit apart. And if you want uber consistency, run 2 cycles up and down, and then charge on the next rise. If you want a little bit more efficiency and are willing to sacrifice a smidge of consistency, you could use just 1 cycle. It'll save you a little bit of time. But some people use much tighter min-max settings and bounce between them many more times before charging. That's fine. I'm generally pretty comfortable with setting them about 50 degrees Celsius apart and running it to the maximum twice, minimum twice, and then charging on the rise. This is specific to the Loring. There's no other machine that has a between batch protocol like this. In an IMF, you have this situation where the bean temperature stabilizes, and all that really matters when you charge is that the bean temperature reading is at the same level every time. You can conceivably do a between batch protocol in about 2 minutes and have perfect success. And also it gives you the option to run a little bit longer. So if for some reason you need a little more time, taking care of some admin tasks or whatever you're doing, as long as you're charging at the same temperature every time, the roast will come out perfectly consistently, which is a very convenient system. It really does not require much finesse to get the between batch protocol just right. When it comes to quality controlling your roasts, of course, at the end of the day, what matters is how does the coffee taste? but there is a lot of information we can collect and track that assists us, especially if we don't want to taste every single batch we ever roast. We have other metrics we can use to make sure that our roasts are on target, and these can be very predictive of flavor as well. So the two most important things to track in your roasting are the weight loss and the color readings. If you buy a color reader, there's really two considerations. One, how accurate is the machine? So a machine might be rated for an accuracy, for instance, of ±1, maybe ±2. So you're paying potentially for accuracy. The other consideration when you buy a color meter is how large is the sample tray. ColorTrack, Agtron, they use very large sample trays that can use as much as 100 grams of coffee to take a color reading. That will give you very accurate and consistent readings, but it will also use a lot of ground coffee. So that can get quite expensive to grind so much coffee just to take a color reading. Also with sample roasting, it may not be practical to use 100 grams to take a color reading. So you might want to get a color reader with a very small tray. So for instance, the DyeFluid Omni shown here, it uses about 5 grams per color reading. And you'll get more volatility in your readings, but you'll save a lot of money using this. And what I tend to do is I tend to use a small sample tray for my color reading, but if a number is a little bit suspect and not what it's predicted to be based on the weight loss, then I'll just take a couple of more color reading samples just to confirm. So I'm generally saving money, and if I have to, I'll take an extra few readings just to make sure that I know what the right answer is. But the larger trays, they do work better, but they can get quite expensive over the course of many years. So this also comes from the DyeFluid Omni. It gives you, for instance, so when you look at on the right, the average reading, those 4 readings that are in the 70s, those are the whole bean color. That ground sample at the bottom, that's the ground number, 97. And on the left, you have this bar graph that tells you approximately what percentage of the bean mass was in each color range. And this is quite useful information because ideally you want to hit a certain average color, and depending on the flavor profile you're looking for, you might prefer a slightly lower or higher standard deviation. A higher standard deviation would imply that there's more bits of beans at darker or lighter end of the color spectrum. That might create a more interesting or more varied flavor profile, but you might also end up tasting roastier or more vegetal, sort of underdeveloped flavors if there's too much bean mass at the extremes of the color spectrum. So please forgive the enormous amount of information on this slide. This is how we track our consistency and our color during roasting, and the weight loss column is very similar in utility to the ground color column, which is the roast value 2. And I recommend tracking both very carefully because both numbers are fallible. There can be errors that lead to incorrect numbers. And if you track both, you'll protect yourself from erroneous readings. So let me give you an example. Let's say the weight loss numbers seem to be very consistent, but suddenly you have a color reading that is much darker than the other ones. That could indicate that your color meter needs calibration. If the color reading is much lighter than you expected, it could be that there was some chaff or some Quakers involved in that sample that threw off the color reading. Likewise, if the color readings all seem on target, but the weight loss seems off target, it could very well be that maybe you didn't tear a scale properly, maybe something was touching the bucket or the scale during the weight loss reading. It could also be that you lost some beans. Like once I had a sample roaster where some of the beans got sucked out of the sample roaster and into the chaff tray while sample roasting, and my weight loss numbers were very volatile, and I realized that because I had the color readings that were very consistent, I realized that something was wrong with the weight loss readings, and finally I opened the chaff drawer and realized, oh, okay, some beans were sucked out during roasting, and that was making the weight loss numbers wrong. So having both weight loss and color helps to confirm that everything's on track and helps prevent you being misled by the numbers. When it comes to what we call the spread between the whole bean and the ground number, please know that what grinder and grind setting you use to take your color reading has a tremendous influence on the color reading. So for instance, if you had an EK grinder with a 1 to 11 dial range, and you took a reading on the finest setting, number 1, and on the middle setting, number 5 or 6, you could have a difference in color reading of between 25 and 30 points between those two, simply by changing the grind size. So it's very important to always use the same grinder and setting for your color readings. And ideally, buy a small grinder that you dedicate to color readings and don't use it for anything else. Because if the grinder burrs get worn over time, the color readings will shift. So if, for instance, you have a coffee bar and you're using an EK for service and the burrs need to be changed every, say, 4 months due to wear and tear, that means that your color readings are going to drift a lot during that 4-month period. Whereas if you buy a small grinder and use it for nothing but color readings, it would probably take 15 or 20 years for the color readings to shift due to the particle size distribution changing due to the burrs getting worn. So anyway, these are just best practices for tracking color and weight loss. Any questions, Christina? Okay. At our roastery, we use an optical sorter, and the optical sorter is quite fascinating. It has a front and back camera, and you can tell it what the acceptable color range is for the coffee beans, and you can tell it what is too light, what is too dark, and what percentage of the bean surface has to be out of the desired color range for the beans to be rejected. And then the machine uses a front and back camera, and when it senses beans that are out of range, it uses a puff of pressurized air to knock the beans out of the stream into a reject bucket. So it's incredibly fast, it's surprisingly accurate, and ideally we use this to remove Quakers, and conceivably it would also eject beans that are too dark, although we don't see those too often. And the reason we remove Quakers is that, first of all, every coffee has some Quakers to various degrees, and there are Quakers that are rather extreme. So if you were to look at a bucket of beans from 2 meters away, and you could tell there were a couple beans that were kind of yellowish that stood out from that distance, those are classic yellow Quakers. Those coffees are, those beans are very vegetal, very bitter, very astringent. But there are many other beans that are a little lighter in color than the better beans, and these tend to be lighter and smoother. And these are Quakers of various degrees that are a little bit astringent and usually taste nutty as opposed to fruity. So if you were to take a smooth, paler bean and smash it on a table and smell the bits of the beans, you should smell nuttiness if it's a Quaker. So when we get a new coffee, we tend to hand sort it we smash a few beans to figure out where the line is between Quaker and non-Quaker. And then we cup the coffee unsorted, fully sorted of every possible Quaker, and usually 3 degrees of sorting between the two extremes. And then we decide which degree of Quaker sorting we think is worth doing to get the maximum improvement in quality without necessarily removing extra beans. So oftentimes, say with naturals, which tend to have a lot of Quakers, we might remove 20 or 25% of the bean mass. With washed coffees, we might remove 10 or 15% of the bean mass in order to get the cleanest, least astringent coffee, get rid of the nuttiness. And interestingly, when you take out the Quakers, coffee tends to have a nice, lingering, soft aftertaste, but Quakers tend to make aftertaste stop short and end with a dry finish. I'm not necessarily recommending that anyone sorts Quakers, but it is an interesting quality control tool that can really help you improve the end result in your coffee. So while we buy the best green coffee we can possibly find, we take it one step further to try to clean it up and make it even better. We're not doing this to save money by buying inferior green. We are literally doing this to just make the best coffee we can, no matter what the cost is. And we find the Quaker sorting to be invaluable for that. Okay, so someone asked for a good but affordable, I'm sorry, color reader or sorter? I forget what you said. Okay. Do you think when they say color sorter, do you mean optical sorter or do they mean color reader? Okay, sorry. We bought our optical sorter from a company in Poland called Coffee Machine Sale, cmsale.com. They've been quite helpful. We're really happy with our sorter. It's got this quasi AI component where you just show it samples of too light, too dark, and just right, and then that trains the machine for a given coffee. There are many other sorters out there, but a lot of them require tremendous training to learn how to adjust the red, green, and blue color spectrums, and our machine is just incredibly easy to use. I don't remember the brand name, but it's the only one that CM sells. Somebody asked if they could use a Baratza Encore for color reading. Yes, absolutely. A small home grinder is perfectly fine. We use a Fellow Ode for our color reading. Really, you just need a small burr grinder of any kind and just use it for color reading and nothing else, and that'll at least ensure that you have very consistent readings for many years. As far as color readers, honestly, they're all relatively equal in their ability to discriminate color. If you want something with a small sample tray, there's Dyfluid, and there's something called Le Brew, Lebrew. I think the guy who started Le Brew used to work for Dyfluid. I think the Dyfluid is a little bit easier to use in the sense that like there's a little tray holder and such, and everything kind of fits together and is pretty tightly built. The Le Brew, the sample tray and the platform it sits on, they're a little wobbly and it's just a little bit more tedious to use. The larger one, like there's Lightells, which is quite good and slightly larger in the tray than these, and then there's the very large trays ones like ColorTrack and Agtron. Very good machines. They do use very large samples. I haven't used every color machine on the market, but I'm sure whichever one you buy, you'll end up with valid readings. It's just a question of whether you want to sometimes have to take multiple readings due to a small sample tray, but then also save money by using smaller samples, or whether you want the convenience of a large tray that gives you more consistent, reliable readings. Yes, so what we do is we do a few sample roasts, and we hand sort the sample roasts and then cup those to decide how much we will sort when we do a production batch. I think that answers the question, yes? Okay. Alrighty. We'll talk a little bit about processing. The main reason that we process and dry coffee, so the processing affects the flavor of the coffee, of course, but we need to dry the coffee at the end of processing in order to be able to make the coffee shelf stable for shipping and storage. If we don't dry the coffee adequately, microbes within the coffee beans are going to literally eat up some of the good stuff in the coffee that we want to end up in our cup, and the flavor will change and the coffee will age much too fast if there's still a high moisture content after drying. So the main processes, there's the wash process. The main difference between washed, natural, and honey is effectively how much of the fruit is removed before you dry the beans. And in the wash process, there is nothing but the parchment left around the beans when they are dried. You'll notice that step 3 in the wash process involves agitating the beans in a water channel. This is the main reason why washed coffees have fewer Quakers than naturals do, is that the beans, or the fruit that floats when washed in this channel, are removed, and those are presumably Quakers or immature seeds. So when you pick coffee cherry off the tree, it's very important that the cherry is optimally ripe. It's very difficult to do well. Most pickers use tricks like wearing a bracelet, or the main processes. There's the wash process. The main difference between washed, natural, and honey is effectively how much of the fruit is removed before you dry the beans. And in the wash process, there is nothing but the parchment left around the beans when they are dried. You'll notice that step 3 in the wash process involves agitating the beans in a water channel. This is the main reason why washed coffees have fewer Quakers than naturals do, is that the beans, or the fruit that floats when washed in this channel, are removed, and those are presumably Quakers or immature seeds. So when you pick coffee cherry off the tree, it's very important that the cherry is optimally ripe. It's very difficult to do well. Most pickers use tricks like wearing a bracelet or painting their fingers a certain color so that they can compare the bracelet or their finger color to the type of coffee cherry being picked. So for instance, if they're going out to pick pink bourbon, they'll have a certain shade of pink/red on their hand, and they'll compare that to the beans to know what color they're looking for. But we are human, and it's difficult to do with precision, and of course some of the beans are not going to be perfectly ripe when they are picked, and those will be Quakers to some degree. Floating them in channels, the fruit in the channels, will help remove some of the Quakers. We generally dry beans to a moisture content of about 9 to 11% to get the water activity and the moisture content low enough to slow down microbial activity so that the beans will age slowly. In the natural process, the entire fruit is still intact when we dry the coffee. This imparts a very intense fruity flavor on the coffee, and tends to decrease what we would call complexity and makes the acidity of the coffee usually a little bit lower in favor of a more intense fruit flavor. And the honey process is quite a range. The honey process has some or all of the mucilage attached, and it could taste quite a bit like washed coffee, or it could taste quite a bit like natural, or anything in between. I would say that in recent years, I've noticed more and more honey processed coffees that taste a lot like washed coffees, but just with a little bit more zing or intensity in the acid and fruit, and really clean, beautiful coffees. Like, I think that honeys have come a long way. They used to taste very much like naturals, and something has shifted over the years where some processors have really mastered the honey process, and they've become very clean and pretty compared to the average honey years ago. And then there's wet hulled, which is mostly done in Indonesia. The hulling is done at a very high moisture content, and the beans are left out to dry for many, many weeks. And this exposes the beans to a lot of changes in atmospheric moisture, and it can lead to a lot of earthy, herbaceous flavors, sometimes like a moldy-ish flavor, because the beans are at the mercy of the elements for a very long time. There's a lot less control over the drying process with wet hulled coffee, and the flavors can be a bit wild. So these are interesting, very low acid coffees, but very high risk in terms of not having as much precise control over flavor as you do with most other processes. So, there's a question about whether there's a difference between white honey and semi-washed. Years ago, honeys were called pulped natural, and it was primarily done in Brazil, and then I believe someone in Costa Rica kind of renamed the process honey for marketing purposes, and honey and pulped natural are basically the same thing. I'll admit there's white honey, red honey, yellow honey, black honey. I don't know what all of those are supposed to mean, if they in fact mean different things. There's a lot of liberties being taken with processing words, and it's gotten to the point where a lot of times people are literally making up what sounds good in the name, and I don't know if there's actually a precise definition for those things. So take it with a grain of salt, maybe ask questions about how a coffee was processed with specific details, because I think that's a little bit, right now it's kind of the Wild West in terms of producers doing all sorts of things and just kind of calling it whatever sounds good, and it's a little bit tricky to keep track of what people mean by different terminology. So there's a question about optical sorters. Yes, they need to be adjusted for every coffee. Some optical sorters are very difficult to use, and some are quite easy to program. I won't discuss brands because I don't want to get in something where I, imply one brand is good and one is bad, and it gets me in trouble. But if you find an optical sorter where you can program it by showing it a sample of the coffee and saying this is good, and showing another sample and saying this is too light, showing another saying this is too dark, then that is so much easier to use than one where you have to master entering blue, red, green color spectrums for each coffee. It's just so much easier to just be able to show the machine a sample and train it by sight. So they can be quite easy to use, and they can be quite difficult to use depending on the sorter. Right. So there's a question about how to roast different processes and things like anaerobics and co-ferments. So there's a little bit of a misunderstanding in the industry where people will generalize and say, oh, when you have an anaerobic, you have to roast it this way. It's not necessarily true. Going back to, remember the slide where we talked about what factors influence how much heat you need to roast a bean? And what mattered was bean size, moisture content, processing, and density. Now, under the processing category, what matters is how does the process affect the strength of the cell structure of the beans? So washed coffees tend to be a bit harder and tougher and need more energy to develop and crack open. Naturals tend to need a lot less. The anaerobic process doesn't seem to have a significant influence on how much energy a coffee needs to roast. So an anaerobic washed might be basically identical to a non-anaerobic washed. So please be careful in the sense that there's a lot of generalizations out there, but really what matters is how strong is the cell structure of the bean, and that can vary quite a bit, and you may not know the answer simply by hearing, oh, this coffee was anaerobic, this was thermoshock, this was infused or not. Like all those things may not have a significant effect on how much energy you need to roast a coffee. So whether it's infused or not shouldn't have any significant effect on how much energy you need to roast it. What should matter is what was the process, regardless of whether it was co-fermented or infused. Was it washed? Was it natural? How strong is the cell structure is what matters in the end. Okay. Hopefully we're caught up on those. When it comes to cupping, please, from this day forward, cup blindly always. It's critical to cup blindly because we all have biases, some of which are subconscious. We may not even be aware of the bias. Even just knowing the name of a coffee, we might like the sound of the name of a coffee, even if we have no idea which farm tastes better. Please do not leave the roasted beans in a sample tray next to the cupping bowls, because that can influence you as well. It's critical that you know nothing about the coffee before you cup it. When I cup with my business partner, Mark, if I set up a cupping, I don't tell him what's in the cupping. If he sets up a cupping, he doesn't tell me what's in it. We just label the bottom of the cupping bowls with numbers. We put the same number on the bags or the sample bin, and we mix them up on the table, and we try to know as little as possible going into a cupping. Generally speaking, I recommend grinding finer for cupping than the historical recommendations of the SCA. The thing about grinding coarsely is that your cuppings will taste a little better if you grind coarser. This is because the lower extractions that result from coarser grind will tone down some defects. So whether you have a green problem, whether you have underdevelopment, whether you have roasty flavors, if you grind coarser, you will have lower extractions, and you will not notice those defects as much. Now, if you were brewing coffee for enjoyment, I would say tone down those defects. But in cupping, we are generally either cupping to decide which green to buy, or we are cupping to evaluate our roasting protocol. In both cases, please do not try to hide defects. Grind pretty fine, so somewhere a little bit finer, let's say, than your typical pour-over grind, and make it as difficult as possible for the coffee to taste good. This way, if you can make the coffee taste great under those circumstances, then you can be confident that it will taste great under almost any circumstance. But if you hide some of the defects by grinding coarser, you may make it that some of your customers are using the coffee in a way that doesn't taste so good. My recommendation is take notes when you break the crust at about 4 minutes. Take notes when you slurp the coffee hot at about 12 or 13 minutes. Take notes again when the coffee's cooled at about 20, 25 minutes. And then and only then begin to discuss with your cupping partners what you tasted. Yeah, that's about it when it comes to cupping. Last thing I'd say is try to use precise wording. So, for instance, if you were to say that a cup tastes vegetal, well, that is valid and legitimate. But what sort of vegetal do you mean? Do you mean vegetal underdeveloped, like a flavor such as corn, hay, grass, or peas? Or do you mean underdeveloped, like when green coffee gets old and it tastes a little bit like a musty vegetable broth? Or do you mean vegetal, like the taste of green coffee that was stored in a very hot environment and tends to have like a similar kind of musty flavor? So using precise wording really helps, and I tend to try to agree with my cupping partners what certain words mean so that we can communicate as well as possible. Okay. Let's talk briefly about green buying. Pretty simple stuff. If you're going to buy green coffee, I recommend cupping numerous bowls of it. So we'll usually sample roast, do a first pass with cupping, and basically that first pass is just pass fail. Is this a coffee we might buy or not? And if it's definitely not, then we won't cup it again. If it shows some promise and is close to the standard we're looking for, then we will cup another 3 or 4 bowls of it in a couple of cupping sessions along with other coffees. This way we are blending it. And we'll do that before we make a choice, a purchasing decision, because some defects, some problems won't show up in every single cup, but if you've cupped the same coffee maybe 5 times, usually by then you would start noticing if the coffee had a problem like phenol or fade or something like that. Anytime you can cup with more experienced professionals, please do. Like, that's invaluable experience. Cupping and scoring and taking notes is all about calibration, and the more other professionals you can cup with, the better you get at calibrating and being precise with your wording. Beginners often make a mistake of just trusting green sellers. It's not that they're bad people. They're certainly not bad people. It's just that green sellers always have some coffees that are aging at their warehouse that they're pretty desperate to get rid of. And if they have 2 customers, one who does their own sample roasting, cups very intensely, takes careful notes, scores the coffee, that person is almost certainly not going to get fooled and buy the aging, lower quality coffee. But the beginner roaster who just calls up the importer and says, hey, what do you have? What's good? And just takes the recommendation of the green seller, they're always going to get stuck with the stuff that everybody else rejected. So if possible, do your own sample roasting, but even if the importer roasts for you, just please make sure you cup blindly, always tasting several coffees at the same time for context, and just be very careful when you make purchasing decisions. Don't do it based on trust. The number 1 rule in green buying is it's better to buy too little than too much. When you buy too much of a coffee, you run the risk that the coffee gets old, and once it gets old, it gets harder to sell, and then it gets older and harder to sell and older, et cetera, et cetera. So when in doubt, be conservative in how much you buy of a coffee, and using fewer coffees on your menu, buying them when they're fresh, using them in a short period of time, moving on to new coffees. That model allows you to constantly offer new and fresh coffees, which is great for sales and great for quality. If you buy a coffee and expect to use it for a year, the coffee is eventually going to start tasting a bit stale. And if you accidentally buy too much, it could take quite a long time to sell it, and then it just starts tasting really stale eventually. Communication with green sellers is everything. That might seem simplistic, it might seem obvious, but very few roasters communicate well with green sellers. So what I mean by good communication is communicate what you're looking for using potentially flavor words, processes, varieties, score ranges, etc. As soon as you get samples, try to sample roast and cup them within a day or two. Try to get back to the importer with notes, even if you don't want to buy the coffees, because usually importers send out samples and never hear back from roasters, and they don't even know if they tasted samples. So just out of respect for the provided samples, providing feedback about what you tasted, why you want it or why you don't want it, what you scored it, these things are a sign of respect towards the seller, but also a way to help calibrate you and the seller so that they understand what you're looking for and what your standards are. So the more and more quickly you communicate with sellers, I think the more they will favor you when it comes to showing you good coffees. It really helps to have a green moisture meter, both to check your green samples to make sure that the moisture isn't too high. If it's above 12%, that's generally a red flag, and while the coffee might taste good, it will probably age quite quickly. But also, when you are roasting, the difference between the roasted weight loss and the green moisture is an excellent proxy for color or development. So if you have a coffee that's 8% moisture and you roast it to 10% weight loss, that's a 2% differential. That is nearly identical to if the coffee had a moisture of 10% and you roasted it to 12% weight loss. So tracking the gap between weight loss and moisture is very helpful, and it helps collect that data along with your color readings so that you have a good sense of how much you have developed the coffee. Yep, sorry. So when it comes to committing to future coffees, there's a lot of trade-offs here. So if you buy coffee further out in time, so let's say you buy based on like the pre-mill stage or the pre-ship stage, you'll have access to more lots of coffee and potentially slightly lower pricing. If you tend to buy spot coffees, arrival coffees, if you tend to buy later in the process, there's usually fewer coffees available to you. You might pay a little bit more money. And the key here is that when you commit to the coffee it determines where the risk gets distributed. So if you buy a coffee way early in the process, you're taking on more risk because there's a greater chance that by the time the coffee arrives, it doesn't taste quite like it tasted at the pre-milled or pre-ship stage. And if you wait for a coffee to be spot sitting in a warehouse in your country, then the risk is almost nil. So depending on your tolerance for risk, depending on your tolerance for how much quality degradation you are okay accepting between the time the coffee was sampled and the time the coffee arrives at your roastery, you may come up with the right strategy for your company in terms of a combination of how far out you want to commit to coffees and how much you want to wait till later in the process, conceivably missing out on some lots, but conceivably taking less risk. So it's a delicate thing. There sometimes is a lot of loss of quality due to shipping conditions, or let's say coffee sitting in a container at a port in a hot country, and sometimes the coffee can get delayed. Let's say it's sitting in a container in Ethiopia for 2 months, and it's cooking at 30 degrees Celsius or 85 degrees Fahrenheit for a couple of months before it gets on a boat, and then it tends to still be hot for most of the voyage. The coffee can change significantly during that journey. So it's basically all trade-offs. And, a lot of it has to do with the trust and the relationships you have with producers or importers, and at the end of the day, whatever conditions you purchase coffee under, it could be very creative, it could be very personalized, and it's really just a matter of you and the seller coming to terms that suit both of you. And there are no rules, really, other than that you stick to your word and that you communicate clearly so that there are no misunderstandings about what the expectations are for everyone involved. Any other green-related questions? Okay. Water activity, the only way to measure it is to get a water activity meter, and water activity is the main determinant of microbial activity within a coffee. So if water activity is high, microbial activity will be faster, so microbes will eat the stuff in the coffee bean faster, they will grow faster, and high water activity tends to make coffee age a bit faster. So having modest moisture content and water activity tends to help the shelf life of coffee. It's very difficult to say how fast green will age or how fast it'll change in flavor. It has to do with the temperature at which you hold the coffee. It has to do with the water activity. It even has to do with the types of microbes that are present within the green coffee. So it's very difficult to generalize. Let's just say that the fresher, the better in terms of flavor. And some coffees might taste pretty good up to about a year after processing. Some coffees might age quite quickly after they're processed. And the more controlled the temperature and the water activity are, the better off you are in terms of aging. It's obviously an option to freeze green coffee. If you freeze green coffee in a sealed plastic package, the coffee will last for many years without any noticeable change in flavor. But if you do freeze green coffee, please remove it from the freezer, leave it out a full 2 or 3 days before you open the bag so that you haven't exposed the beans to the moisture, room temperature air before they have defrosted. Mm-hmm. Yes. So the question is, how soon after roasting should you cup? I would say that if you cup right out of the roaster, you can get a sense of roast development, but you may not get a good signal when it comes to how roasty the coffee might taste. I find that some roastier flavors don't show up right away and they tend to get worse about a day later. So most of us tend to cup about a day after roasting. If you roast very, very light, especially with an air roaster, your coffee might need a lot of rest before it tastes optimal. So it's a little bit tricky with very light air roasts to taste it a day after roasting and anticipate what it's going to taste like several weeks later when the coffee has reached its peak flavor. There was a second question there, sorry. So the question is, are roasting defects evident while it's still degassing very early after roasting? Yes, definitely. It's a little bit easier to tell roast problems the day after it's roasted, but usually by the day after roasting, you should be pretty safe in terms of evaluating the roast quality. So the key really with sample roasting is if you need to make a rapid decision on the roast quality or whether to buy a green coffee, it just helps to not sample roast uber light, because if the roast is extremely light, you won't get as good a read on how it's going to taste several weeks later. But if you roast a tad darker, it might help you get a sense of what the coffee is going to taste like when the flavor peaks many weeks after roasting. Okay. So there's something called water quenching, especially in some larger roasters, where at the end of the roast you spray the beans with water to stop the roasting process rather abruptly. Quenching is generally quite bad for flavor. It tends to make coffee taste a little hollow, and there's a little bit of a weird flavor that's a signature of quenching that's a little bit hard to describe, but it seems a little bit polluted or muddled in flavor. Even if you quench quite conservatively, there's a strange thing that happens to the coffee where, because it cools so rapidly, some of the cells in the beans collapse and they don't quite grind the same and they never taste the same. So quenching is very risky. It's really generally done by larger companies that want to add a little weight to the coffee as a way of saving money. And it's in some poorly designed larger roasting machines, quenching is the only practical way to stop the roasting process without a lot of momentum being involved. So for instance, if you had a very large roaster and it took, and I've seen this before, it takes in some machines a full minute to eject all the beans from the roasting chamber. What that means is the beans that come out first are quite a bit lighter than the beans that come out last. And something like quenching tends to help stop the roast so that all the beans are very similar in color. Are we caught up? Okay. When it comes to sample roasting, there's a lot of sample roasters out there. There's a lot of ways to get good sample roasts. Oftentimes you'll be roasting coffees that you're not familiar with, that you've never roasted before. So the first try on a coffee, I would say if you have, let's say, a profile for wash and a profile for natural, pick one of those two profiles that's most appropriate and have a target development time that has generally worked for other coffees of that process. So for instance, if you tend to drop your sample roasts at 40 seconds development time for wash coffees, start there. And then based on the weight loss and possibly the color, you might make some adjustment to the development time and try again if the first roast didn't land in your target range for color or the difference between the weight loss and the green moisture. It's very difficult to predict what a brand new coffee will do in the roasting machine. And at least controlling for development time in sample roasts gives you a pretty good chance of success on the first try and an excellent chance of success on your second try. Okay, so that is the entire presentation. This was a bit smaller of a group than usual with a few fewer questions than usual, so the presentation fell a bit short of the usual 3 hours. If there's any questions about things I covered or even things I didn't cover, you're welcome to ask them and I'll try to field some of those questions now. But after that, we'll wrap up and we'll start some new discussion threads about specific machines and specific questions. And everyone in the group has the next 2 weeks to ask as many questions as they'd like. There is a protocol for posting curves, so please wait until tomorrow. I'm going to post the protocol. And then please, when you post a curve, try to include all of the requested information so that we don't have to go back and forth too many times to cover all of the important information. But I'll give it a couple of minutes if anyone's got any follow-up questions based on the presentation. Christina, just let me know if anything comes through. Okay, so someone asked, how do you correct a dramatic drop in the rate of rise? I'm assuming it's probably a crash happening during first crack. The best you can do really is find the highest gas setting that doesn't make the ROR go flat or rise and just stay on that gas setting through most of the crash. Most ROR crashes will last approximately 35 seconds. So usually what I would do is, if I see a crash beginning, I would note the time at which it began. I would wait 25 seconds, and then I would begin lowering the gas, because I would know that the crash had about 10 seconds remaining, and I need to be a bit proactive in lowering the gas to prevent it from eventually flicking. And I don't want to lower the gas any earlier than that 25 seconds, because I don't want to help the crash get even deeper. Okay, so there's a question about planning for roasts, and this person mentioned that sample roasting cannot be transferred to production roasting, which is pretty true. For instance, if you have a development time of 40 seconds in your sample roast at 100 grams, and you go and do a 10 kilo batch in your production roaster, the development time is going to be a lot longer than 40 seconds. It won't transfer. Likewise, temperatures, times may not transfer. The best thing you can do is have a very consistent sample roast system where you're using only one or two profiles, and note how long those sample roasts take for each coffee relative to other coffees. So let's say you had a baseline that most coffees took around 8 minutes. You might say, well, coffee A, washed Colombian, took 8 minutes. Coffee B, washed Colombian, took 10. You might assume that coffee B, when you finally production roast it, is going to take approximately 10 seconds longer in the production roaster than coffee A if you use the same profile for each coffee. So you can kind of get a relative roast time from the sample roasting, and then make some assumptions about how much longer or shorter the roast time of the production roast will be. But you can't really scrape that much more information from your sample roasting. With a little bit of practice, you will have a sense of, okay, here are my settings for a large washed bean. Here are my settings for small washed beans. Here's my setting for large natural beans. Here's my settings for small natural beans. Like that template where you have maybe 4 extremes can help you start out with any new coffee. And I don't think you have to be precise about everything to have a successful first roast. And your development time, you'll probably have pretty consistent standards for development time range, and you probably want to end up in that range for most coffees of a certain type, like let's say large and washed, and go from there after the first batch. I do accept curve data that was tracked with pen and paper. Just be aware that there won't be as much resolution in the data if you did it by pen and paper. So, we'll be a little bit more limited in what we can glean from that, but we'll work with what you got for sure. So if you have a coffee that has a dry mouthfeel, regardless of how you roast it, if you are talking about in cupping, then the answer is almost certainly that it's being caused by Quakers. If you are tasting that in percolation brews, let's say like a V60 or espresso, it could be due to channeling. So I would say, first of all, cup it to avoid channeling being a factor. And then if you still get that dryness, it's definitely from Quakers, and you may not be able to influence that through roasting. Yes. Yeah, I when I set up this class, I thought I would be back in the U.S., but actually I'm still in Australia, and I got up at 2:30 to do the class. So yes, the sun is rising. Mm-hmm. If you are attempting to adjust the air-fuel ratio of your burner, there's going to be a system for doing that. It's going to be burner specific, and you should get a gas expert to do it for you. It's not something you necessarily want to mess with on your own. So I hope that's an adequate answer for now. So there's a question about whether you need higher charge temperatures for higher grown or denser beans. The answer is no. Again, I really want you to see charge temperature as just the last step of the between batch protocol. Have one between batch protocol for each batch size, and then just adjust gas settings for different beans. So again, density is not that important. So if you have something like a high grown small bean Ethiopian, it may be on the denser side compared to most coffees, but what's more important is that it is a very small bean, and that small bean is not going to need nearly as much heat as, let's say, a Kenya AA that was grown at a similar altitude but is a much larger bean. Okay, so there's a question about whether, I think I understand it, whether development time is associated with ROR at first crack. Sort of. So if you reach first crack at a higher ROR, you've tended to do something, you've helped development a little bit by doing that. Now, usually that means your DT, your development time, is going to be a little bit shorter because your ROR is higher, so you're going to progress more per unit of time during first crack. If you make the ROR drop gently, not too quickly, a really steep crash is going to inhibit development. But if you make the ROR drop more gently and you can stretch out your development time a little bit extra, you can squeeze a little bit more inner development from a coffee. So if you enter first crack at a low ROR, you're going to need a lot more development time for sure. I hope that answers the question. It's a bit of a tricky question. Okay, so somebody is asking, how do you accentuate various flavors in coffee? This is harder and trickier than everybody wants it to be. So if you say something like, I want my coffee to be fruitier, well, first of all, you have to decide where are you in terms of roast level. If you roasted pretty dark, it might be fruitier by roasting lighter. If you underdeveloped a coffee, it might be fruitier by roasting a little bit darker. So there is no magical like roast curve solution that says this coffee will be fruitier, this coffee will be more acidic. It's not so simple. You really have to say, okay, here's my curve, here's my color, here's my moisture, here's my weight loss, here's my cupping notes, and then look at all that and say, should I be roasting darker or lighter? Am I seeming to have any kind of problem with inner bean development relative to roast level, or am I getting any roasty flavors? And then you can work from there. But that's what the group is for. So if you have a situation where you're trying to change the flavor of a coffee, if you post a curve with all of the requested information, I will help you with that. Please note that so many times people come to me and they say, the importer said the coffee is going to taste like this, but it doesn't. Now, it may very well be that no matter how you roast it, you can't make it taste like that. It's very common that importers will taste coffee when they're fresh. They will come up with very nice sounding tasting notes, and either the coffee isn't as fresh or it got damaged in shipping or etc. And you'll never be able to squeeze those flavors out of the coffee. So just because the tasting note somewhere says raspberry and lemongrass, it doesn't mean that you can definitely get those flavors. But what we can do is we can look at the tasting notes you do have and the data you have, and we can try to adjust things to get closer to what you want. So there's a question about whether you can apply more energy during first crack in an air roaster to mitigate the crash. Yes, you can. You're not going to pay the same penalty that you would in a drum roaster. I would say there's very few times where you need to do this. But yes, you can totally do that and not really have any bad side effects from it. Okay, there's a question about some of the curves shown here show some sag in the beginning / middle portion. That is not a problem. Mostly that is an indicator of a couple things. One is that thin, fast probes are going to show that sag and thicker probes will not, because every data point in the ROR curve is an average of several data points before it from like an interval of say 15 or 30 seconds. And in a faster curve, you're just going to see a steeper drop in the ROR, and then a flatter, saggier curve in the middle of the roast. That's just that's just always going to be that way when a probe is thinner. A slow probe is going to show a much more rainbow-esque decline, where it might even be straight or might even be a bit humped, but it won't sag. Naturals tend to show this pattern a little bit more than wash coffees do as well. I'm not sure exactly why. It probably has to do with a slightly different pattern of moisture release from naturals than washed. But the bottom line is it's not a problem. As long as your first crack ROR is at the level you want it, it doesn't matter if you see a little bit of a sag in the curve earlier on. Okay, so there's a question about ideal weight loss during roasting. That completely depends on how light or dark you want your coffee to be. So at Prodigal, most of our weight losses hover around 10.5 to 11.5% for our filter coffee. Our espresso, straight espresso, tends to be about 12.5. Our milk-based espresso tends to be about 13.5. For reference, I would guess that the average Starbucks roast is about 20% weight loss. So you can see there's quite a range of options, and 100% determined by how light or dark do you want your coffee to be. There is no right or wrong answer here. When it comes to choosing a sample roaster, I look for a few things. I prefer an air roaster to get easier development and hopefully less roasty flavors. I prefer a sample roaster that collects a fair amount of data, because the more data I collect, the more chance I have to be able to get some insight into how to approach the coffee in a production roaster. And I really like automation in sample roasters, because we do a lot of sample roasting and it takes a lot of time. We actually spend more time sample roasting than production roasting at our roastery. And it's invaluable to be able to push a button, let the sample roaster manage itself for most of the roast, and then be doing things like weighing out green, measuring moisture, measuring weight loss, measuring color. And it allows us to, the automation allows us to multitask, and that's really incredibly valuable. So there's nothing wrong with a manual sample roaster, but you will find that automated sample roasters just allow you to collect a lot more information and do a lot more in a short period of time. Okay, the question is, how can you tell if your charge temperature is too high? You can't, in the sense that, again, what matters is the drum temperature, not the charge temperature. And your drum temperature is not known. So if you get roasty flavors in your coffee due to conduction, the cause could be in your roast curve, but is more likely to be in your between batch protocol. And I'm happy to work on that with you, because it's got to be a case-by-case basis, but it is not due to a nominal high charge temperature. Please note that extra conduction can also come from having the RPM level not be optimal. So if you're getting roasty flavors in a drum roaster, it's either that your RPM is off, your airflow is much too high, or your between batch protocol is giving you too hot of a drum. But we can figure that out pretty easily by looking at your data. Yeah, I think we answered that pretty well. Okay. There's a question about appropriate sampling rate in an ROR curve. I think a 15-second interval is perfectly fine. If you have a very slow probe, like let's say you've got a 6 to 10 millimeter diameter probe, set your smoothing settings as low as possible and your intervals as low as possible. This way you get a little bit more noise into your curves. If you have a very, very smooth curve, you're getting a little bit less useful information. So there's a question about whether there is a percent weight loss I would consider underdeveloped. I can't say that with precision, but I would say that if your weight loss is not higher than your moisture content, you very well might be underdeveloped, and probably you need to be somewhere, like for the washed coffee, you probably need to be about 1% higher than your moisture content, and with naturals, maybe about a half point weight loss more than moisture in order to be fully developed. But it can vary a little bit, obviously. So there's a question about the percentage of time a roast is spending in the Maillard phase. So this is a tricky discussion because the internet loves talking about the Maillard phase, and for some reason, the most common advice you'll see on the internet when it comes to roasting is the solution to everything is extend the Maillard phase. Now, what's a little bit suspicious about that to me is that I've literally never seen anyone say use a shorter Maillard phase. So how could it be that a longer Maillard phase is just always better, right? It's always suspicious when someone says more is better, more is better. I don't think it matters too much. Now, if we go back to the example that I gave where with an air roaster, 7-minute air roast could taste identical to a 14-minute air roast. Well, presumably that 7-minute air roast has a lot less time in each phase than the 14-minute roast does. And what's happening there is that this almost identical chemical reactions are happening in both roasts. They're just happening faster in the 7-minute roast. So it's not that you're getting fewer Maillard reaction products, it's that you're getting more of them per unit of time in a fast roast, fewer of them per unit of time in a slow roast, but in the end, you might end up with nearly identical cups. I think that focusing on certain percentages for each phase is a little bit misguided because trying to serve two masters never works, right? If you're trying to balance the phases, you might end up reaching first crack at a very low ROR, maybe crashing, maybe flicking, and maybe not developing your coffee optimally. And all of that to try to manipulate the phases, but it wasn't worth it, okay? So what I'd like you to focus on is how high is your ROR when you get to first crack, and how long are you spending in the development phase? And if you focus on those two things, I promise, and follow good principles as far as airflow, BBP, drum RPM, then I promise you, you are going to potentially have all the quality you can possibly squeeze out of your coffee. You're not going to miss out on any potential quality. There's a couple of other problems with the Maillard phase measurement and kind of focus. One is that it's very hard to know for most people when the drying phase ended and the Maillard phase began. There's a lot of assumptions around that. There's a lot of inaccuracy about when to mark that. And the other thing, just to put a final nail in the coffin of that idea, is that the Maillard phase actually doesn't end when first crack begins. It actually continues through the end of a roast, assuming you don't go into second crack. So there's just been a lot of misinformation and bad assumptions around that whole phase balance discussion, and I think it's not worth focusing on. What's worth focusing on is RPM, correct airflow level, good BBP, and then focus a lot on reaching first crack at a reasonable ROR and having whatever development time is giving you the color and weight loss results that work to your taste. Yeah, so we talked a little bit about the pyramid gas settings for air roasting. The idea simply is that in a drum roaster, the drum absorbs and stores a lot of heat and then releases it later in a roast. In an air roaster, you don't have that heat storage, so you have to continue applying more heat later in the process. So if you don't keep putting heat into the process in an air roast, the air roast curve will slow down precipitously. So in a drum roaster, you have this very hot, very stable environment, and when you lower your gas settings, the drum does some of the work for you. In an air roaster, you have to peak the gas a lot later and hold it at a high setting a lot longer, since you don't have the drum to help push the roast along later in the roast. Yeah, so there's a question about whether I have experience with the bullet. I do. If you post a curve from the bullet in the group, I will help you. And because the drum in the bullet is the heat source, it is an induction heater, it becomes critical to not use the highest power settings, 7, 8, 9, in the bullet, because the drum just gets too hot. So the strategy we're going to use in the bullet is very similar to other drum roasters in the sense that we are going to use the lowest possible fan settings so that we can use even lower power settings, and that way we manage the drum temperature. So if you post a curve from the bullet, we will work on that, and hopefully we'll make some really good progress for you in your bullet roasts. No, there will not be a latte art for roasters glass, mostly because my latte art sucks, but yeah. Yeah, I'm sure. So I've made a lot of comments in the past that the internet likes to talk about, but I generally don't drink too many naturals, but there's a few that I've liked here and there. Yes, Prodigal sells naturals. We do have a business to run. A lot of people love naturals. We do our best with them. Historically, I've always tasted the Quakers in naturals and found them a bit off-putting. And a lot of naturals have quite a bit of fermentation in the cup. So, and to me, quite often too much. But that said, there are some naturals that have more modest fermentation, and now that we have an optical sorter, we can really clean up the Quakers, and so we're enjoying naturals a lot more than we did in the past when they tended to be dirtier, a little bit too fermenty, and when we didn't have a way to remove the Quakers. But I still do drink mostly wash coffees. Yes. Okay, so I think we've covered all the current questions. I'll wrap up the video here. Thank you for tuning in. Christina, thank you for your help. Yeah, everyone's welcome to post future comments and curves in the group, and I will monitor the group a couple of times a day, every day, and answer your questions. And everybody else is also welcome to participate in discussions about other people's machines and coffees. Please don't be shy. Please feel free to post a lot in the group. It's really helpful for everyone. The more activity there is there, the better. There are no bad questions, just whatever concerns you, let's talk about it and let's work it out. So thanks very much.